Hello. Oh, okay. I already see someone coming in. I'm starting in 2 minutes or so. I'm just getting everything set up. But while we're at it, yeah, I just need a few moments. Thanks for popping in. We're going to look at the aUSD exploit. Okay, how can I share this? Where is the link? Hi, we're going to look at the aUSD exploit in just a minute. Just need to share it on Twitter. Oops. Okay, so okay, good. So we are live here. Join the YouTube live on the aUSD exploit. All right, so it is starting, and I have to see, take a look here. Yes, there was an exploit on aUSD, so let's start out here. And let's give a little bit of context. Let's start here. So what happened? On 14th August, Akada stopped operations due to an exploit with reported 1 billion aUSD being minted. What happened here? And we have a little bit. So this is the tweet that I saw initially, where I became aware of the story. Let me check here. Okay, so it looks like Akada was just hacked due to a bug in the IBTC aUSD pool. Here's the attacker wallet. Yeah, so this is the first interesting thing here that we're seeing. So we're looking on Subscan. This is the Akada Subscan, and you can still see it. You can still see 1.2 billion aUSD that was minted. So let's take a look at what happened here in the activity. And how this live stream is going to go is that I'm just going to look at this. So a lot of the stuff that I'm seeing here, I'm learning for the first time too. And I just want to learn about everything that was talked about this today. So maybe what are the questions we're having? How did Twitter react is also an important question. How did the Akada governance react? Was Karura also influenced? I think this is an important question. If you have additional questions here, let me know in chat, and we are also looking at them here. And I'm also thinking if we should maybe launch a Twitter space at the same time to add a little bit of voice here. Maybe this could be interesting. So let me start the Twitter space, and we are doing this on 2 channels at the same time, and I'm trying to let you listen in on this. So starting a space. The $1 billion aUSD incident. I'm going to record the space, and this is going to happen now. Okay, so this should start now. Yeah. Trying the base here to discuss. Okay, hey there, I see quite a few people joining already. If you want to join the discussion, you can do so. What I'm basically doing here is that I'm doing a YouTube live, and I was thinking that we could also if you want to join the discussion, you can do so. What I'm basically doing here is that I'm doing a YouTube live, and I was thinking that we could also, if you want to join the discussion, yeah, so you can do so. Wait, what? Okay, so what I'm doing here is, hi everyone, you can join on the stage here. What I want to do here is discuss what happened a little bit. I want to learn what happened today on this story. I'm also taking notes at the same time, and I started a YouTube live stream. You can find the link on my profile, and what I'm doing is I'm taking live notes basically, where I'm gathering all the information I can find. So first of all, if you want to speak here, let me know. If you followed the story here today, let me know, and we can discuss it a little bit. And other than that, let me just join here. How can I share this into the space? Yes. Okay. Does someone want to speak here? If not, I would just be starting to share the knowledge that we know so far. But I wouldn't enjoy to talk alone. So please feel free to just say that you want to discussion here. Okay. So what we're having here. Okay. So this story broke, I guess, roughly 13, 14 hours ago, and it started with one account having more than 1 billion aUSD, 1 billion aUSD. I think it's 1.2 billion aUSD. And a few other pieces that we could connect is that governance, Acala governance seems to have reacted pretty quickly. I will take a look at that in a few minutes. And it seems also that the user that could mint the over 1 billion aUSD was actually not really a black hat hacker, but so it was a person that somehow was cooperating, or we can see a transcript. If you join my YouTube live, you can see that the person was participating. Maybe I can share the screenshot also on Twitter, and we will just do a live coverage of that. So this is something that got reported on the Acala Discord. On the Acala Discord, someone was posting screenshots from the person that actually participated in the exploit or was responsible for the 1 billion. Okay, just a second. I'm trying to get a screenshot of this. I see that 2 people want to speak. Okay, I'm having GM intern here, and I'm just getting you on stage. Please behave. And hi, what can you tell me? I see GM intern here. Oh, I see also JC wanting to speak. Hi, everyone.
Hi, everyone. Good to meet you.
Hi, good to have you here.
Cool. Can I add something?
Yeah, please.
Yeah, I've been following the story, but I just wanted to maybe get your input on how this differs from the Moonbeam hack in the sense of, how they sort of halted the chain. And, obviously they passed governance proposals, but I'm not sure who actually voted on that, or if that was actually like a technical committee like Moonbeam. yeah, just to get your thoughts on that, because I haven't been able to find a lot of information on how they actually halted the chain and, what that really means for the Polkadot governance process. And yeah, does that make sense?
Yeah, I think so. For me personally, I was on vacation when the Moonbeam story happened, but on Subscan right now, if you're looking at the tweets that I share on Subscan, tweets that I shared or the tweet that I shared, I'm having the live stream, and on the live stream right now on YouTube, I will be changing the screen to the council motions. So what I saw to also, if someone here knows anything more, I'm getting more people on stage. If someone can share some knowledge. Okay, so what I'm sharing on my screen right now is that governance did become active, and I have to check out a little bit how many governance actions took place today. But we can see the block number. So, okay, that happened quite a lot. That happened quite a lot today. So within 1,000 blocks, within 2,000 blocks, I see quite a lot of actions that were being executed today. Was someone there for the Moonbeam incident and can tell us what happened there?
I mean, I followed the Moonbeam, hack, but I didn't actually take part in actually voting. So yeah, I can't really comment on that one.
Yeah. So I don't know how fast Akala is going, but I see here that within the space of roughly, so there were within the space of within the time span of 2,000 blocks, there were roughly 20 governance actions performed today. I don't know how fast. Let's see. If we have 12-second block times, it's 5 blocks per minute. That is 300 blocks per hour. So 1 hour is 300 blocks. 1,000 blocks would be 3 hours. 3 hours and a bit. So they seem to have executed about 20 governance actions within the last day or so to mitigate the issue. I think we would have to take more time to look at all the requests. But as far as I'm aware, from their Twitter, they said that they got 99% of all the tokens that were minted in error. They have them contained on the Akala parachain. And maybe, I'm not sure, does anyone know yet how many accounts were affected? Because this would also be an interesting question. I'm putting it down here.
Well, I don't know exactly how many accounts were affected by this, but what I know is that a lot of people that were into the pool, they have like millions of dollars in their accounts now worth like aUSD. So everybody's like, some of them are happy, some of them don't know what's gonna happen. But it seems like Akala is gonna take actions on that too, because like suddenly people that have like a couple $1,000 are now like literally millionaires.
Yeah, so it would actually also be interesting to see what was the cause of the issue.
Okay, so tell me, I don't know, like I would like to make a point here because I've seen a lot of misinformation in terms of the Canary network, which is Kusama. I would like to make this point because so yesterday when it happened, I was awake. It was late at night here, but I was following everything and I was sharing all the information with, of course, my Twitter followers and all that. And it's very important to understand that this issue is directly related to the Hanson fungibility palette that Akala uses. And they use this palette to make aUSD fungible between Akala and Karura, which means I'm not a technical person, but it was basically created with the intention of allowing aUSD to serve as the native stablecoin for both Kusama and Polkadot. What happened there is that they were, I think this is a new code or a new pilot, because when I went to GitHub, I saw the proposal from, I don't know, from July, something like a month ago. So it's something that if it follows the days that are on GitHub, that means that it's pretty new. And they were texting like, it's a common back from Karura and Akala. So I don't think there is a way to test something if you don't test it in both parts that are gonna be involved. I might be wrong because I'm not a technical person, but so many people are like, why it wasn't tested before in the Canary network? But like the idea of this was connecting both. So I guess they were doing that in both because they needed to connect both. So a lot of people are saying, well, the Canary network doesn't work then. But in this case, this bridge was between Kusama and Polkadot. So I guess if you need to test something, you need to test it with both parties involved. So
I,
I don't know if someone has a more technical perspective on this. I would love to hear it.
I actually have an objection on bridge and the interlay. I actually checked this upscan on the Explorer wallet, and most of the balance transfer from the Akala aUSD was from the pallet incentive and the Honzon. So I think what happened is that the user was actually actively using DEX module for long, and somehow there has been a transaction where he just kind of interact with a DEX module for like 50,000 USD value of assets, but somehow he got like a reward of like a 500k aUSD out of the treasury. So it's kind of weird that people are now like saying that this actually happened from the bridge. But if you just look at the balance transfer, it all happened from the pallet incentives inside the Akalis parachain right now. And what kind of really tickles me is that, like, how is this aUSD kind of got minted from the treasury? I mean, it's over collateralized stablecoin, so it has to be backed by some kind of collateral to mint it. But I don't understand these Akalas, right? Akala's like announcement saying that this has been misconfigured to just mint the aUSD out of the treasury right now. I haven't looked up in the treasury code yet, but I think full analysis will be out in a day or so. But I can't be sure that interlay is not directly related, and this is not about XCM. I think it's mostly about pallet incentives in the home zone and the maybe under collateralization happen in the treasury, because this thing should not happen. I mean, aUSD, even as it's over collateralized, it cannot just be pulled out from the treasury and then just sold and then just lose a peg.
Yeah, I think that's a very interesting point actually. How did the aUSD even come into existence? I have a guess, but it's just a guess. I don't know this by any facts or so. It's just I think that the aUSD protocol is so diverse and has so many parts that I would assume that some modules can make assumptions about creating a balance. And maybe this specific submodule didn't respect the balance for a certain reason. And so it could create... what I'm saying is maybe the submodules can mint and burn aUSD as long as they keep the balance or the system intact. And maybe this submodule had a bug that minted the aUSD in the wrong amounts.
Well, for that, I think you can check in the loans of the trade in the Akala right now. I actually looked up the code, and then what you can execute on that runtime module function is that there's actually like a loans module that the call is kind of like a adjust loan or something, adjust loan with the debit value. I think I was kind of embarrassed that looking at the value was like a negative, but it seems like they had a meaning on that, setting up like a signed bits of it. But what I'm also worried about that is that like most of the parachains though, like they might actually use a physical type like unsigned int in their primitives in their parachain, and I don't quite understand how that would actually apply in XCM for the currency trade, because currency trade object can actually have like a different types but just share the same functionalities. So that was what I was worried about. But as long as just after I saw that the exploit, the balance transfer was almost happened from the pallet incentives, that's when I was actually changing the focus on the from the loan to actually to check if the aUSD has been over collateralized ever since.
Yeah. I'm also seeing that Cyrix Taylor is here in the space. Taylor, I saw that you gathered a lot of information. Can you share a little bit of what you learned? So maybe you want to come on stage and share a little bit if it's possible for you. So what I see from the account, the primary account that minted so many aUSDs, that it became active 18 hours ago. So it was active 3 days ago, and then it took a pause of 2 days and became active 18 hours ago. And I still have to look through all of the transactions, but it seems like it didn't stop after. So the count discovered maybe how the exploit worked, and then it just kept working and repeating the same actions over and over again. So add liquidity, claim reward, swap, add liquidity, swap, claim rewards, swap, for quite some time. Seems like the person got very excited.
Yeah, absolutely. That's when I saw like 500k reward, and then the reward amount just kind of got exponentially like greater, because at the start I think it was like 5,000, and then it just grew into like a 1 billion or 2 billion or something. Yeah.
Right, and then at some point, 15 hours ago, it was locked. Then the person tried for some time. Oh, there was a transfer, an attempted transfer. Oh, the person tried to transfer aUSD. Seems like a cross-chain transfer, yes. 2004, someone tried to transfer aUSD. So it seems like the activity got stopped. The protocols were locked by governance or whatever. And then there was an attempted transfer 4 hours later. So the person tried to perform transactions and basically got stopped in the act, tried for 5 minutes, and then took a 4-hour break, and then tried to transfer the aUSD out. Okay, so I'm going to find what is parachain 2004. This looks interesting.
Yeah, I mean, thanks to Taylor, I was able to see what happened in the account, and it seems like I think we got a clue about it. Yeah. Is there any details that you can refer about this, Taylor?
Hi, Taylor.
Hey guys, hey, give me just a few minutes. I'm doing a thing outside right now. Just can't really speak at the moment, but I'll swing back here in a few minutes.
Okay, great.
Okay.
Tommy, parachain 2004 is Kala.
I see that is Moonbeam on Polkadot.
Oh, sorry, please tell me it's Moonbeam, my bad.
Right, so here on Polkadot, I see that parachain 2004 is Moonbeam, so the person tried to swap it out to Moonbeam. Maybe they tried to rescue it into EVM, and from there, have a faster game. And then they tried it once more, didn't work.
You know what? Yesterday when everything was happening, well, today in the morning when everything was happening, everybody was looking at it, and you know, there were rumors that this person wasn't a hacker at all, that it was basically just some user that got benefited from the bug or bug or however you call it. And it seems like it, but I would like to see if Taylor wants to say something about it, because it seems like it was a normal person. It wasn't a hack at all. It wasn't a hacker at all. So, see what Taylor says.
Mm-hmm.
Yeah, so what we have seen on Discord, someone posted this as a transcript, and it said, it seems like the person that created this shared screenshots of this. I don't know with whom they shared it, but someone reshared it on the Akala Discord. And the text, so you see two screenshots. One screenshot basically, different balances like AKA, R.dot, and so on, and then the 1.2 billion aUSD balance. And the other screenshot is from the aUSD IBTC liquidity pool. So I think to act as a proof. And then the text message says, it was all to put liquidity into the liquidity pool. I only pray for my real funds. I hope they are not affected. Well, the liquidity pool IBTC aUSD just came out. I wanted to add liquidity, and when I put in about $600, that began to generate returns of thousands of dollars. And at first I thought there were too many digits, and it wouldn't be that much. But when I wanted to withdraw the rewards, I actually verified that my balance went up to 70,000 aUSD. With it again to the LP, generating many more returns and so on several times until I got the results in the screenshots. So it seemed like a regular person that repeated this over and over again. The question would be, did other people see this and try to repeat it?
Yeah, I mean, I think he has done a lot of things, repeating. First he started with a small amount, and then he just took all the money, I guess. Yeah.
Yeah, so the person was active doing regular color stuff, taking a loan, and at some point today or yesterday they removed AKA aUSD. No, that's not right. They maybe have done this to add liquidity. Yeah, okay, so the person removed liquidity on one side to add new liquidity to the aUSD IBTC pool here. And yeah, they liquidated other LP positions maybe to add even more liquidity. That's right. So they must have discovered it right away. It wasn't like they discovered it over some time. Yeah, they swapped in more and more tokens. And then at one point they claimed, let's see if this was already the issue. Substrate is still so hard to read, even if Subscan and all the. Okay, I see that we have more people wanting to speak. Hi, Electrovenic. Hi, Jimmy Tedeschi. Do you have anything to add to the story today? Okay, so if anyone wants to speak, just speak up. Meanwhile, I have gathered a list of questions. So, were any other accounts affected from the tweet?
Alice, can I ask a question? Jimmy here.
Sure, I can hear you. Hi.
Hi, hello. Kank, is it possible? I wanted to ask you because when I see from Akala information that they state that the issue was misconfiguration of the IBTC aUSD liquidity pool. How the misconfiguration of IBTC aUSD pool can have such effect or whatever? How can IBTC pool have impact on the whole protocol?
I mean, so that's what I feel kind of weird too. So I think it's fundamentally kind of contradictory that aUSD has been minting from that pool. I mean, it's over-collateralized stablecoin, right? Then you need the collateral to put in, but then why does it have to be like a misconfiguration to mint the aUSD in there? I mean, it doesn't make sense, right?
Yeah,
so
it seems like the USD was minted from the IBTC pool. It's like ridiculous.
I know, it's really weird. I don't know why. So I just asked a question on Twitter. It's just so weird. Yeah, but a nice point. I mean, this is a really nice catch. I mean, we should know about this and to try to ask Akala on how they kind of happen to do this thing, you know?
Because should be like minting from over collaterals, not from the any pool, right?
Yeah, absolutely. Yeah, you're right. Yeah.
Yeah, so the effect should come from so we're seeing different extrinsics that are being called, and I see one extrinsic was to swap, then we see one that was add liquidity, and we see the claim rewards. I think these were the main extrinsics. So I would say the extrinsic that is responsible for the issue would be claim rewards. So we would be looking for a bug within the claim rewards and misconfiguration. The question is how many ways are there to configure a liquidity pool on a Kala, and if this was a new module that was deployed, or if it is the same module every time and just a single parameter was created wrongly. Maybe we can track this back in time, because I mean governance actions are not that common, so it should actually be possible to trace this back. Does someone know if this is voted by the general democracy or by the council?
Are you talking about maintenance mode?
Say again?
Were you talking about if maintenance mode is voted by democracy or council?
Yes, the initial pool that was configured.
The initial pool. I have a quick question. So if there's already existing KBTC and aUSD pools on Karura, like why wasn't this vulnerability found on Karura? Like, was there something different from that KBTC and KUSD or aUSD pool on Karura compared to the Akala pool?
Yeah.
Because I thought a lot of the whole point of Kusama was to, not test in prod, right?
That's also a good point. But I think one can actually try that on Kusama and then see what happens.
Is that maybe the relation that I was talking about with the Hansen thing? Because maybe it doesn't allow to like prove it without going both ways to like Akala and Karura. Or maybe it does, and they just decided not to try it first on Kusama. I wanted to know like exactly what the relation between Hansen and the pool led to this happening, because they have been mentioning the Hansen like since the beginning. So yeah, I'd like to see that if that was the thing that prevented for trying first on Kusama. So if someone knows anything about the relation, please let us know.
But the whole thing is you should be trying like everything that you're gonna do on your dot chain on Kusama first, so that if it's got some major clusterfuck like this, let's find out on Kusama, right? So if there's anything that's different, then they've just not used the Kusama chain correctly, and you're kind of asking for trouble, right?
Well, no, I totally understand what you're saying, and I agree with that. But I was wondering, because they're being like talking a lot about the Hansen, and now we know that the Hansen is some kind of communication between Akala and Karura. If it was possible to test only on one side, so I would like to know like what the relationship between the Hansen and the liquidity pool, and how this everything came together to result into the minting of a 1 billion aUSD. So that's why I have this question also in my mind, but I am trying to be like open-minded to see if like the team clarifies why they didn't test it before on Kusama, because everybody's like, that's why we have Kusama for, like, it's impossible for you, it's impossible for you to say, oh, we're gonna have something new and we're gonna go directly to Polkadot and let this happen. So maybe we're gonna have some answers, but I don't know if someone is very technical. Maybe that person can give us a clue about that. Or
my suspicion is that, I think from the Ethereum DeFi scene, what stablecoin project usually do, aUS stablecoin for the USD, I saw people just putting their stablecoins in the dexes and then just believe that it will be safe. Just, even though it's not like over collateralized, they just put it there and then say it's safe, because curve price equation mechanism kind of secures the asset trading with the low price impact. maybe Akala was thinking that they're too safe, maybe. But I don't really understand why this 1 billion aUSD has been staying in this treasury without thinking about this over-collateralization at all. Like, why? I mean, but the aUSD, as I see in the subscan, was not even a pair. It was just in treasury, just stuck in there. I mean, like, was it like a burned aUSD in the treasury, or did they just kind of store it there just for incentive? Or, I mean, if they do that, I mean, are they even a stablecoin project? And I don't know. It's just really confusing for me right now.
Yeah, I think we need to bring a column member to this call and
Yeah.
tell us the truth of everything that's going on. But well, the good news, like so far that we have, is that the Akala team is in contact with the person, and since it was a normal user, it seems like the funds are gonna be back on Akala's hands. So that's good. I mean, at least we know that from the team that they are already in contact with that person.
Juliana, one thing I can add is the Hands-on protocol is not just about the connection between Akala and Karura. Hands-on is the core of the aUSD protocol. So it consists of many parts. I just added a tweet, and I also added it to the space, so it should be available in the space also. I just can see it.
Okay, perfect. I see it. Thank you.
To my point of view, I just like want to be on Akala's side this time, because I think they reacted great. Because we see some depegging, yes, but it close to $1, and they did everything that they was able to do, just like from my point, and the peg is quite close. And I think this reaction right now won't do harm to the Dogtat ecosystem, because if they react like in a way they should do, that will bring more value, and we have this experience. Not everything can be tested, you know, like there's a lot of exploits, especially in the pools. So I think they did a great job. And what's happening right now is a good experience for the whole ecosystem.
Yeah, but we had Kusama, right? So, okay. But yeah, I mean, it's good. Maybe they were testing in Kusama, maybe. But okay. Yeah.
I think what Electrobanic is trying to point out is that the team acted like very fast. I was following the chart today in the morning, and it was crazy how fast it was recovering. I didn't I mean, I was trying to swap something, but at the end I was like, yeah, it's not worth it because it's moving too fast, and I don't have time to make the whole operation, and I don't have a bot to do that for me. But I think like that's a good point. I mean, the team is acting and all that. But yeah, we're looking for answers why this is not, why this wasn't tested on Kusama first. We could have avoided a lot of things happening and this whole bomb into the crypto ecosystem, because we were like kind of safe in terms of hacks or like problems like this. Like every single ecosystem was having issues, and we weren't tainted by that. And now we are, and everybody knows it. And so everybody's questioning the position of Kusama as a canary network. So I do understand what Electrobanic says, but I also understand what Heinz or whatever your name is. And yeah, we don't have the answers so far for that. I just hope the Akala team can fix this as soon as possible, because they are a very important part of the Kusama ecosystem.
Yeah, I was meaning like from the image point of view. So I know guys who made a lot of money from that, because, you know, there was a time that it was depegging to 1.1 and like this, and after this. And a lot of guys who make like trades on KuCoin and everybody, they said like, yeah, we did a lot of money, but we like we like how the ecosystem react, and that it was like under control in just like a few minutes like this, and everything comes into place. So this is, I think, a plus to the ecosystem and Akala as well. A part of it like being hacked.
I'm still not sure if it is being hacked though. Like, you know, like from the Terra Luna experience, like, I haven't even verified Akala has been printing aUSD based on its collateralizations, and we don't even know what treasury funds do and how it can just mint out of thin air. So, I mean, this has to be clarified by the team. Otherwise, it's quite hard for them to get away, because SEC and this Korean prosecutors are now investigating on this. Like, for example, Do just minted USD out of thin air and then swap with the MIM and then change it to USDC. I mean, if those kind of things were kind of possible in this system, like, we need to get into this legal system though, like right now, because that's what's happening in Korea.
I have just found the original governance call that created the IBTC pool, and I'm skimming through it. It's a little bit hard to read because it's pretty long. It has 300 lines. But it seems a little bit to me that the incentives were also set up with this call. I shared it on Twitter. Let me also share it with this group here. And I'm trying to read through it and understand if the incentives were also already set up with this. Maybe, can we annotate? Is there a way to annotate, Jason? Yeah, what I'm currently hunting is the misconfiguration question, because this is really interesting. This could get to the core of what is being discussed here. So it seems like there was a dispatch call to first create the pool, and then what they're having is this incentives module. And the incentives module should create aUSD. No.
But my question would be, did anyone check, for example, construction of KBTC protocol and aUSD pair, like the pool? Because when the Akala said that it was misconfiguration about IBTC aUSD pool, I'm wondering, is it is the same configuration set on the KBTC USD pool, or I don't know, maybe Kank, you can put some lights on it. I don't know if you checked it already, but my question would be why, are those pools like KBTC, IBTC, aUSD configured differentially, or this is the same configuration and the same case can happen on the KBTC pool?
I'd say the
Well, I
fact that
haven't looked up
nobody's
the Kusama subsquant, but I need to look at the transaction they submitted. But I actually checked the code for the incentives, but it seems like most of the codes are kind of set on runtime, meaning that it's not set in the code itself. So I would have to basically be a slot in the subscan in both network and then just find out what happened in there. But yeah, I would happy to investigate if I have to. Yeah.
Guys, what do you think? How to avoid these things in future? So what should be checked and what procedures should be running?
And my question would be also, will this event have bigger impact if aUSD were merged, combined, I don't know how to say it, on the Karura and the Kala?
Let's
Taylor
hear
is ready.
Taylor. Yeah, let's hear Taylor first. Yeah.
Hey everyone. I think the big thing to help prevent these in the future is to have, good test coverage in their unit integration test, to have both happy and bad path test cases that, try malicious things and try, to validate if there are authorization controls around these function calls and what have you, and tests like adding liquidity to the LP. Looking at their hands-on test, I didn't really see any like bad path test cases or any. It was very like bare bone test cases around that functionality. So that could have caught it potentially. And just having environments that they can run this in that aren't exactly live immediately, I think is a big one.
What I would say that needs to be fixed is that we haven't even really been able to check the reward with the APY on how much reward we get in the time passed. So when I look at the code, it has been like a multi-reward with some trade objects, and I couldn't really figure it out how much what the APY will be or get some query on how much pool that I will get for each reward. I think there is something error happened in that kind of trade in the code, and I can't really figure this out as it's those like parameters are just all set in the runtime. So I would just say we need to focus on more showing the current state of the DEX pool and then overall the chain status, because it's really a pain in the ass to just look over to Subscan right now. I think at least I hope Subscan actually make something great as Etherscan, but maybe it's too hard. But that's one of the things that I would prefer. But also, I think Acala needs to really specify that their stablecoin is kind of over collateralized. We haven't even got the overall statistics on how much aUSD have been minted across this Polkadot ecosystem and how much collateral is just backing it.
Yeah, so there is there's some TypeScript code that Acala publishes that allows you to query the pools and see the collateral and debt and other factors that go into that pool. It was actually funny because like right before this hack happened, I was helping Blinken and because he manages WAG Media's treasury, and we were like discussing this, and I was running those scripts, but the scripts don't actually see into the IBTC pools. They only have, I think, 4 pools that they show data on. So, I would say suggest those scripts, but they don't have full visibility into things. But, getting all of that metric data analytics is key. Like I was talking to Zach XBT last night, and he was like, that was like a comment he made too. He's like, analytics for this is shit. There's nothing out there to really see into these networks. And that's just kind of on us in the community and, these projects and getting that, this is all also new. Everybody's always been keyed towards EVM based technology. And this is not that. It's many degrees more complex in a lot of ways. And especially with the added, this does have added EVM support. Like this Hanzon client has EVM precompiles, and you call into Solidity contracts with this client. So it takes time to build that stuff out, but as we gain adoption and over time, I think that'll progress and become a lot better.
Yeah, I think we need to use Indexer a lot just to show the status. I mean, Subquery and Subskit is already there, but I think people are not really using it a lot just to show how they're doing.
Yeah, I mean, and you have things like with XCM transfers and stuff, like when we were first doing things with Moonriver, when we did transactions from our chaos.collator into a smart contract, like the transactions didn't even show up on Etherscan because the mover we had was actually still substrate native mover that was being transferred, which Etherscan didn't have any purview into. So you had to actually go to Subscan to see the transactions, even though they were like EVM substrate wrapped transactions.
I see. Yeah.
But as far as as far as I checked, the Alcala states that the funds are still on chain in the Alcala network,
That's
and
correct.
and the Alcala said that I don't know. Just there's the question will come afterwards, but I don't know how it's possible because they said that maybe they're gonna revert the transaction with the governance, but how it's even possible?
Yeah, that's totally what they'll probably do. We saw the same thing last year. Carrera was hacked through an XCM exploit with there was like a lack of validation check, and somebody was able to like spoof a 10,000 KSM transfer into Kala that they didn't really have. And the Kala did something Carrera did something very similar where they just put the network into maintenance mode, and then we're able to do a governance proposal that essentially reverts the state of the blockchain back to, resets
I see. Okay.
reset states on that. And so they'll do something, I'm sure, similar here. I do see that it actually minted the 1.2 billion has reached out to them on Twitter here, and basically said in Spanish, I only was trying to add liquidity to the LP, and that generated millions in what I see now in a matter of half an hour. Like I think he realized he had a free money glitch and was, I think things got really out of control for him.
Yeah, well, when you look at this transaction, when he got stopped after about 2 hours, and then he took a break for 4 hours. Then he tried to transfer tokens out of the system.
Yeah, just some commentary on the person. They definitely were not sophisticated in this. They used their long time like DeFi and DGen account. They had transactions going way back. They had some subsocial metadata, like their email address, and they'd received bill coins, and so we were able to find their Twitter profile and pictures of them and stuff. It just really struck me as this was somebody that was just a user that found a bug in something, and it got way out of hand, I think, for them.
Yeah.
AB, I just sent you a DM with that message. You could probably share it in here at this point, because he's posted it publicly on Twitter now. So I don't know if you want to post that up in there.
Where is it?
I
posted it.
Let me see. I'm not seeing it in my DMs.
And Discord DMs, dude.
Oh,
check.
Okay. Too many. Should I share it here?
Yeah, go ahead.
Okay, just a second. I share it from my phone. Too many. I have my computer open and voila, everything. Okay. Yeah. So I guess got overexcited with newfound powers and then didn't know what to do. It's pretty common.
Yeah, that's my assessment of it. I mean,
billion.
anybody more sophisticated would have been way more subtle in what they were doing, and would have XCM or wormhole that out of there really fast. They had pre-planned this, I think.
Sure if I'm finding.
So I think in this case we could call it like a Lucky Akala, because the guy that found this wasn't very sophisticated. We can say that.
One point, I see Taylor found him the transactions from Binance. So what do you think? Will Binance support Akala and give all the data, and what Akala could do to the person if it was a different person, not that we already know? So it's not the white hacker, but the real one.
So I don't know if Binance would cooperate with them. I'm sure that would depend on their relationship. I can't really comment on that there. But I think there is other metadata left by that person that they probably wouldn't even have to go the Binance route. And it looks like this person at this point is reaching out to them.
So can we say we're lucky enough that this person is kind of public?
I think he didn't even try to transfer the money out now that I look at the transfer transactions, because I'm seeing, yeah, so aUSD has 12 digits and he didn't try huge transactions when trying to transfer the tokens out. I think it was just,
I think that there was the try to send the XCM transfer to Moonriver.
to Moonbeam, but so
Yeah.
okay, in the first transaction, he tried to transfer out $6, and in the second, so they tried to transfer out minor amounts. This might be a bit more. Yeah, and then $1, and even that failed, and then they gave up. So didn't even try to get out huge amounts, but I mean, could have been a minor transfer, and then later on more. And if it would be out on Moonbeam, that would have gotten out, yes.
Okay, then the question, why did the PEX happen? If nobody knows about it.
So the question is what the misconfiguration was. For example, what would be interesting if it was just be a few zeros too much or too little about how much reward should be minted. Because when it is a claim call, it could be that the module is minting new rewards.
Yeah, I think based on what they're saying with the misconfiguration, it could very well be like a decimals issue. I don't know that for sure though, but that could be a good guess.
I'm going through the call that created the incentives, and it doesn't look like they're creating huge incentives. It doesn't really look like that. Maybe, I mean, the question is the IBTC, I don't think they created a special module. This looks like a call, it looks like every other call to me. I don't think they created a new palette for this. And if it is the same palette like every other palette.
I just noticed that the person that got this, it was like a Spanish speaker, and he actually was commenting in my thread that I created, and the guy was just so scared, man. Like he was just so scared about what happened.
Just like Taylor said, he wasn't like a sophisticated guy, like purposely trying to do this. He just found out it was working and then got really excited and tried it multiple times, right?
Yeah,
Right.
he's like a Spanish speaker person that was like really concerned about what was happening after he saw that everything like wasn't online. So
Monkey sees free money. Monkey tries to get free money. Monkey sees that it's not smart. Monkey gets scared.
Yeah, Monkey could have got a nice bug bounty, but Monkey went a bit too ham. Tried to put too much monkey money.
Okay, so I have looked about 20 minutes at the call now that created the rewards, and I'm not getting anything out of this where this could be misconfigured. The zeros check out here. So I think I will stop looking at this call. I start to feel I get crazy. But what I will try now with the remainder of my evening is to write a little bit of code that checks how many rewards were claimed, and this creates something more interesting. Okay, but what I gather here is that actually the most important question, and I think from my perspective, so I think exploits happen. You can have better tests. improve the process. But I think one question that needs to be answered is how that amount of aUSD could have get minted, and if they are improving the process here so that one sub-module or the claim rewards of palette cannot create that huge amounts, because this is somehow an indication wasn't relying on all the information it should have used. Okay. Yeah, are we having any other questions that people like to discuss? If not, we could just come back together in the future and see how the situation develops. I feel a little bad for the color team that they have to work through the weekend here. That's really unfortunate for them.
Yeah, but the best thing I think as a conclusion for the meeting is that we have a very active community which is not which is taking care about the protocols, and then that's why we gathered here. And this is like I think that for the future that it brings some ideas that we should take care about our protocols, and even more that the teams are doing this. I know it's ridiculous, maybe, but but this is what we can do. Like try to give the best possible security from the community to the protocols.
That is right. And it's also interesting to see that actually the main part of the discussion is basically the protocol, how it can be improved or what was the issue. And it's interesting to just observe that it's not really an issue that people now think that aUSD is dead. So I think this is also important to see in comparison to other things we saw around and other incidents happening. I think there's a lot of trust here at the moment that Akala will make it right.
Yeah, I would say that what we're doing, Nicholas, like still supporting Akala and the ecosystem, and that's great. So we understand the mistake. We'll we will to investigate it, but still Akala is going to the peg, and I think everything will be okay. So that's great.
Right.
Hey, I have a real quick question, if I can ask.
Sure, go ahead.
So my community has been asking this question a while. So it's for Alex and Bob. How long schlong? Thanks.
Getting really excited for the coming week at Mangat, I can tell you.
Looking forward to it. Thank you, Admin.
Thank you very much, sir. It was a pleasure having you here today. I see that we convened for an hour. We discussed a lot of questions. I'm going to look at the on-chain data now, and I think we can all go our ways now. I see one more. Oh, Taylor. Hi, Taylor. We were just about to conclude the meeting. If you don't have anything more to share. Right. Okay. Then I suggest I'm concluding the meeting here. If anyone wants to follow me while I code an on-chain scraper to see what actually happened on Akala or Polkadot, you can do that by following my tweets and then see me on YouTube. And I'm wishing you a good day or night wherever you are. And we're looking forward to see a good conclusion of this event, hopefully. Goodbye.
Bye-bye.
Bring the GM parachain. Bring the GM parachain. We're waiting like 2 hours more.
Mr. AMB, send me your address. I'll send you a GN on-chain on the GM parachain.
GM.
GN on.
All right. What you just witnessed was the 1 hour discussion on Twitter. What I will now be continuing with is coding a little bit, as long as I see some viewers here on the chat. you can just be here and I will just comment on what I'm doing here. Okay, basically, and I will try to follow your chat messages here if you have any suggestions here, but I will speak out loud what I'm doing. Okay, what I'm interested in here is that I see that the attacker claimed rewards, and this was the basic way of how they could get that many tokens. I think this is part of the issue here. So what I'm going to do is I'm going to sample the chain for those data, and we're going to look at what I am seeing. So this is my scraper. This is part of the Subscrape project, and what it does is it goes to Subscan, this page here, to the backend API, and it queries some data. And so since I'm seeing that it has to do on the Akala chain with the incentives palette and the claim rewards call, this is where I'm going to, and I want to get the data out of there. There is some boilerplate code. This is not too interesting for now. And what I'm going to do is to claim then to fetch the data here. But I'm not getting any data, so maybe my call here is wrong. Maybe it's like this, claim rewards. Seems like it. Timeout. Shouldn't timeout. I want to stop it. Okay. Transfer sample aUSD incident. Oh, no sound. I'm sorry about this. No, you should actually have sound right now. So I'm streaming sound. Streaming sound. Let me hear into this. Let me hear into this if I get some of my own sound. No, okay, so yes, there is sound. Okay, yeah, what my system is doing now, it is going through the most recent claim rewards calls, and I'm doing this for the last few thousand calls. This should be enough for now. Let me claim a few more. Yes. Okay, so we have got the claim rewards for the recent days. And now that I got the data, so I have it now here in this data. Let me show it to you. So if I have my events here, I guess it's not yet a JSON. Is it a JSON? Let me see. Parents. Yeah. Okay. I guess I have to unwrap it now. This is code that I have written previously for another project. Okay, so what we have here is one individual claim action, and it claims against a certain pool, or in this case a loan, it seems. Okay, so what I would do now is I would create a list of every claim action that was performed against the blockchain, I guess, and I would be filtering it against just this specific liquidity pool. So we're fast forwarding here a little bit, and we're going to look at different elements until I see that specific element. Okay, so token AKA pool ID. Yes, that's still the wrong pool. It's L dot. Okay, it seems like L dot is a popular pool. So maybe I'm looking for if params one and I want this to be the pool ID and we want a key to be there. So the key should be, what is the other key? The key is not loans, but DEX. And I'm doing a breakpoint here. So I'm looking for this specific call here. Does this work? Does it work? No. Okay, pi is free. Okay, I'm not getting this in the whole script. Okay, so loans, maybe I can do like this. Okay, what do I get here? DEX, yes. Okay, so DEX in, okay. I'm getting every call that has the DEX. And now the second thing I'm getting, actually I could just say, if DEX, if pool ID equals and then I have an object DEX equals another object DEX share, and this has call 0. Can I copy this? I'm sure I can copy this. Params 1. Okay, so this is, yeah, this is the regular work of doing on-chain investigation. It's not super spicy all the time, but over time you get to some interesting stuff. Okay, maybe I just have to type this out. And column 1 is token is AK. Closing this. Column 1 is another object, and the token is aUSD. Closes. Okay, let's try this. One, two, three, four, 3, 4, 1, 2, 3, 4. Why is it having an error? Okay, maybe I cannot compare this. Comparison. Oh, it doesn't like this. Why doesn't it like this? You should like this. What's this problem here? Was not closed. Not closed. Okay, this one is actually closed. Free open, free closed. What is your problem? missing something simple here. Ah, this should be a list. This should be a list likely. Is this a list? This should be a list. No, it shouldn't be a list. There's a big share also. Something easy. Okay. Okay, this works. No. Fuck's sake. Okay, let's do it in another way that just works. If dex in, then dex is params 1 pool ID, and we go from here. Not here anymore. Okay, so we're seeing the DEX object here, and we're looking if there's a DEX share in it. If DEX share in DEX, and this would be, yeah. Okay. Okay. So we're querying the Akala chain and we're looking for any incentives claimed. Oh, did we pass this? Did we pass this? Okay, so we're querying the Akala chain and we see if there's any DEX chain object DEX share object that claims the incentives. If DEX share index, this should fire. If DEX share index, okay, what's wrong here? We have the DEX object. And we have a key that is called DEX share. Yeah, okay, we have, and now we're checking if column 0 token is AKA and column 01 is aUSD. No, actually not. We're looking for something different. We're looking for the IBTC, no, the aUSD IBTC pool. Is it this one? Foreign asset. So aUSD is on one side and foreign asset is on the other side. And foreign asset 3 is the IBTC pool. Hi, Paolo Saga. We're currently investigating the aUSD exploit and I'm looking at on-chain data. And I'm working a little bit through the basics, but we almost got it covered here. And I'm just making sure I'm finding at least one call here. But let me just find it. So if any of the DEX share, we can actually say if DEX share column 0 if token in DEX share and DEX share column 0 token equals aUSD. Okay, and then we're going to see what we find in this pool here. Okay, so let's start looking at all incentive claims where someone claimed aUSD on one side, and we should find a claim. This is L dot liquid crowd loan 13. Why liquid crowd loan 13? Is this L dot? Seems like it. Foreign asset 4. Okay, we find foreign asset 4, so we will also find foreign asset 3. Let's just go for it and see if it works. So we say if foreign asset in DEX share column 1 and DEX share column 1 foreign asset equals, so is it string 4? We don't know. No, it's a pure number, equals 3. Okay, and this would be the interesting case. This would be the case where we say someone actually claimed from this pool that was affected by the exploit. Yes, and we find it. Okay, we find it. Now the question is, how many of those claims do we find? So I'm just introducing a counter, and let me count it for a second. How many people, or no, how many extrinsics were sent that actually claimed? So this is I equals I plus 1. And I think I'm commenting this out because this is just confusing my GitHub Copilot. Okay, so let me see how many we find. Print I. Whoops. Why is it? Oops, this is one transaction too early, or one time too early. 0. Oops, this can't be right. This can't be right. Oops. This should happen here. Okay, let's go for it. Okay, so we find 256 transactions of people actually claiming from the IBTC aUSD pool. Okay, now we're putting all of this data into some form of a data structure that just helps us. So let's say we want to have all claims, and this is just the list. Yeah, this is just the list. And so all claims, and here we would be appending a single item. Okay, and we append all the data that we're interested in here. So what would that be? So let's look at a single event and let's actually see what is there. So someone called incentives claim rewards. Yes. Okay. Yeah, let's just look at the parameters. What are we interested in here? Okay. So what we're seeing is the account ID. This could be interesting. This is who wanted to claim. The pool ID, this is what we just looked at, and the currency ID. Not really sure if this is interesting. And what does balance mean? What does balance mean? I mean, we're not having it here. We're not having it here. We can take a look at it. Why not? Balance. Okay, so if someone called this, let's take a look at it here. If someone is calling this, this is the attacker's call. So this is the parameters. I mean, let's just take it and see what comes out of it. So we would be appending, and I think this is where I can steal from the past here, from my previous code base. So yeah, let's steal from this. So event, the event index, event block timestamp. This is looking good. Yeah, then why not? Let's transfer it to the date. And then we are transforming the account ID. Okay, this is what we also did in the past to get some data. Now let's get, okay, we have the address. Let's take a look at the currency ID actually. I'm not really sure if this is different from time to time, but let's just put it out there and we take a look at it when we have it in Excel. So this is params 2, params 3, and params 4. We don't care yet what is the actual thing here. I think this will just make a lot more sense when we look at it in Excel. Okay, for everyone who is new here, we are looking at the Kala aUSD incident. We're just in the process of transforming the data, and with Subscript, which is a library that was created explicitly to scrape substrate chains. And I'm looking for the transform that I just created. Yeah, so it's here and it's empty. Okay, what do I need to do here? I suppose I need to put it in a file. Writer swaps. Okay. Yeah, originally I called the swaps. In this case, it's all claims. So I'm just outputting the data, and then we can look at it in a way that makes more sense to everyone, which is in an Excel file. And this would be where we can start with an actual investigation. So we're getting the data now from the chain. Let me give a few columns here. So what we have is an event, index block timestamp, a date time, an address, and then we are having 3 amounts that we don't know yet what they mean. So one was balance, and what was the other thing? I think it was claim or something. So balance 1, and I'm calling this balance 2, and I think we should be able to go with this. Yeah, this is no longer swaps, but this is all claims now. Okay, and so if we go with this, yep, we got an output now. Account claims, yes. Okay, so I'm showing this here. Okay, and what we're going to do now is, let me create a Google Sheet real quick. And so I'm importing, upload, dragging this file here. Okay, and append to current sheet. What are we going? Let's detect it and let's just see if it works. Okay, yes. So what do we see here? Now, we do have the on-chain data for this Akala incident. And what we see is that this original attacker, he did not really do an attack, but let's say the original exploiter, the person that originally found the exploit, and they performed different activities on-chain. And we wanted to find out what was actually happening. So add liquidity, claim rewards, swap with exact target, add liquidity, swap, claim rewards. Basically 3 activities. Add liquidity, swap, and claim rewards. And it seems likely that the incident was somehow related to claim rewards. So this is the data that I just grabbed from the chain. Just grabbed it with this script here, and we are now seeing the result of this. And what we have here is the event index, which is basically the block number plus running number within the block of the extrinsic, then the timestamp, and then we have a date, and then we have the address that was claiming this, and this is actually transformed. Let's check. I think this is the substrate format, but maybe we should use the Acala format instead, because 5 is substrate, but we're dealing with Acala addresses. So let's take a look at subscan on what is actually the Acala format, so that we can use the Acala format. Okay, so Acala has prefix 10. Okay, so I'm running the script one last time. Whoops. I'm running the script one last time, and I'm exporting the data with prefix 10. So 42 is what substrate is usually doing. I guess it's an inside joke from Gavin Wood. Okay, I now exported it with the ID number 10. This should be Acala. So let's wipe all this data again. We're deleting this, and we are importing again. I'm doing an upload. Acala claims. This is the file. It was just created, and append to the current sheet. Automatic detection of everything. Right. Okay. Yes. And so we are seeing this address format here. First thing that would be interesting for me as a data analyst is how often did a certain account do a certain claim. So what I'm doing here is a pivot table. So I'm doing a pivot of everything here. Yes. And I'm adding this to a new sheet. And what I do here is that in the rows I want to have the address, and in the values I want to have the event index, and I want to count the unique instances of the event index. Okay, and what you're seeing here is these are all the addresses that performed a claim in the given time. How many addresses was it? Okay, let's sort this. Let's sort it by the count unique, descending. Okay, so what we're having here is the different addresses that performed the attack, so to say. This one is interesting because it starts with a C. Actually, I was expecting all addresses to start. Interesting, with a 2. Interesting. Okay. Yeah. So let's compare this with the attacker. The original exploiter, and we see it starts with 26J and ends with T2K. T2K. 26J. Okay, so this wasn't even a person that claimed the most often. There were other people that claimed more often. It seems like the pool just became active. So maybe this person was just the first one to even perform the activity. Very interesting. Okay. Next thing I'm interested in is to check out those numbers here. And actually, I did not properly transform this. This is not funny. Do we have anything here in the second column that doesn't say 0? No. So we could ignore the last column. But this one is interesting. What does this balance refer to? Is this the balance of aUSD? Is this the... Oh, okay. So this might be what is claimed. So someone... Maybe this is the result? Is this the result? Could this be the result? Okay, someone is claiming rewards. Let's take a look at this. Or is this their own token balance? That wouldn't make real sense. No, these are the only params I'm getting. Okay, maybe let's take a look at a single incident. So it seems that people claimed ACA, foreign asset for this is Interlay. This is the Interlay token. They claimed ACA, the Interlay token, and aUSD. ACA, the Interlay token, and aUSD. Very interesting. And you see here, right here, this is also a huge amount. Okay, first of all, I'm going to remove this column. It doesn't add any meaning, and we're going to unwrap this, and we're going to unwrap this one also. Okay, just so that we get a little bit more meaning out of the data. So how we're going to do this is we're going to remove this last column here. We also remove it here. Bam, 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 bam. Balance. Okay, and then this one called balance, we just unpack it. So we're actually going for the balance here. But not here. Here. Okay, and here I'm going for the currency ID. Could I unpack this even more? Can I go for the value here? Let's try it. Does this work? Without crashing? No. New. Okay, let's see if we can grab hold of our data. Okay, value, no. No, 0, okay. Maybe I should just leave it. Maybe I could go for values, and then I could go for 0. I could go for next. Oh, that's lame. Ether? Ether? No. Built-in method values of dict object. Okay, how about list? It's not iterable. What do you want me? Okay, maybe keys. Maybe list. Okay. Yeah, let's just go with this, and I'm not able to go through this. Okay. Anyways. This is good enough. Okay, so we're going through the data one more time. We're getting an export here. Export looks good. I'm taking the data. I'm deleting the original data. And I'm saying file, import, upload, and re-add the data. This time it's cleaned up a little bit. Okay, this doesn't look good. File imported successfully. I created a new spreadsheet, did I? I didn't want to create a new spreadsheet. I wanted to append. Good. Okay, and now we get the token balance, and we should actually divide the token balance by 2. Let me create a new column here. No, not by 2. We should remove 12 digits, so that's divided by 1 to the power of 12. Is this right, like this? Yeah. Doesn't work for very big numbers, it seems. That does. Okay, balance. So I will do this here the next time also. Good. So we see that there are different balances here. So we want to filter by, I mean, let's go for everything. Yeah, we see that there are very big aUSD claims, and I actually cannot even comprehend the number. So let's transform the number in a way that is comprehensible. And I'm not interested in digits. Okay, the last claim was a huge one. So the interesting thing here is this the amount that was claimed, or is this the amount that the account had in their balance at that moment in time? So I would be looking at, can I look at this account index? This is an extrinsic index. Yeah. Yeah. Okay. And so incentives, claim rewards. This seems to be the balance of that account in that moment. ACA was transferred. aUSD was transferred. Yeah, this is the actual transfer here. This seems to be the amount of tokens transferred. So 1, 2, 3, 4, 5, 6. Oh. Yeah, so we have, yeah, so that's 1.2 billion AMJX transferred. This seems to be the offending activity. This seems to be the call that minted the 1.2 billion aUSD. Very interesting moment here. I think we got the offending call. I think we got the offending call here. Okay, let me see. Okay, so this was the offending call. This was minted for the last time. Let's check this with the time. Does it match the timing of the profile? Yeah. So sort A to C. Ah, I should have. Okay, I should have marked this one. So let's take some notes here. Okay, this was the call that actually minted this huge amount of aUSD, it seems. So let me sort this by date and by time, and then we see, yeah, so you see here, this was one of the last claims. This was one of the last moments that someone could claim. And then they froze the system, then they deactivated the system. And you also see that the Interlay token got minted here. And what do we all see here? We also see small amounts of ACA being minted, but that didn't seem to matter here at this moment, this point in time. Yeah. What was the last one? 40 million. Is this the same guy? No, this is someone different. Someone minted 40 million. Okay. Can we find the same person minting ACA here? Yeah, minting 15 million aUSD. And nothing for some long time. Okay, 33,000 aUSD. He must have gotten excited. He must have gotten excited when he minted $33,000 in value. Obviously. Okay, so the guy mints 33,000 aUSD. Some other stuff happened that wasn't too important for him, I guess. Okay, so can we maybe create a sum here? Yeah, so let's filter it for aUSD. So let's filter for a claim of aUSD, and then let's just add together the balance, and this is the sum. So this is the aUSD that was minted. Someone minted 79 million aUSD here. Someone minted 1 million aUSD. Someone minted. All right. Okay. I think this answers one of the questions that interested me the most. So how much aUSD did actually get minted? Yeah, and I think it will be up to Akala to determine how much of that. And I think, so it seems like, I would guess most of this was minted in error. You can see that people minted, everyone that claimed actually claimed huge amounts, everyone. So the misconfiguration must have been valid for everyone. It doesn't seem to be like a hidden exploit or something. I think everyone must have become aware of this issue. Very interesting. I think I'm going to share this one. I think I'm going to share this one on Twitter. And I'm going to hide the number of transactions. Okay, and let me sort this by the sum of balance. Okay. Maybe, yeah, join. Thanks, sir. So all the addresses that claimed aUSD. Seems like everyone, seems like we have a few new millionaires. Too bad they won't. And how much they claimed. Okay. Let's keep the fun out of this because maybe this is not fun for everyone. All the addresses that claimed are aUSD and how much they claimed. Okay. Hi, Paulo Saga. Thanks for the encouragement. I have a little bit more time. I think I will continue. I take a 2-minute break just to fill up on water, and then I'll be left. So see you in a minute. Okay, hi, I'm back. I think before I'm continuing, I will share my results with the Akala team. I would expect that what I have found by now, they have also found, but on the off chance that they are doing something differently, I will be sharing my results with them. So please give me a minute to do that, and then we will do a little bit more of an investigation. Okay, this is the sheet, right? Okay, so we're calling this extracted aUSD. I'm sharing this. Anyone with the link, copy link. Okay, good. I shared my results here to Akala, and I think what I'll do next is to investigate if there were any transfers out. I think this would be interesting to see. This actually looks interesting to me. So, okay, what I would do now is I would open one tab for Subscan and one with my list of results here, and I would just be going back and forth and comparing what people did and if it looks like they were aware of the exploit. Maybe check Twitter if there's something. Haha, cool. Thanks guys for sharing. It's really cool that you're joining me in this experiment. I have to make sure your tab stays open. Ah yes, this is where I see your comments here. Okay, good. So yeah, this is the original offender here. Let's move forward to the next one. And what I will be doing here is I will be showing again how many transactions they had. So this is columns, event index count, no, not columns, values, event index count unique. So this is the number of transactions that we are actually counting that this person performed. And you see this person was more active, even this one. Okay, but let's look at this person. Maybe there was an account that wasn't talked about so much. Inter, how much is it worth? aUSD. Ooh, you see this? You see this? 80 million aUSD. Okay, but only 30,000 in the account. And we see some successful XCM transfers. Okay, this is interesting. This might mean that someone transferred out money, and this could get expensive. If this is 80 million aUSD, okay, so someone transferred aUSD. Okay, maybe someone was quicker and smarter and more evil. Claim rewards. Okay, let's see when the last claim was for this account here. This could be an evil attacker. Okay, I'm filtering this down to only show aUSD. Okay, and we're filtering this down to just a single account here. I want to see what this guy did. This could be interesting. Okay. Closing down a few tabs here just to clean up. Okay, I think I can close this one. Okay, so yeah, look at this. This guy was much faster. He realized what happened. You see, claim, claim, claim. Claim, claim, claim. It was super quick. This is an evil one, and I think I have to report this to another whitehead friend who should take up the investigation here. I have to report this. Just a second. Okay, let's see what he did. Let's see what he did. Just getting back to you for a second. I'm taking a look at. Okay, I still see a few of you online, so I will keep going. Okay, so the last action was at block 9047. Yeah. So what did he do? Swap aUSD to dot. I could crowd on dot. And kept transferring out tokens, claiming rewards. Okay, this looks evil. So let's look at where the tokens went. You see there were continuous transfers out. Okay, let's look at the last one. It might be the biggest one. Let's look at the last one. It might be the biggest one. So yes, transferred out IBTC in the amount of, this can't be too much, 2000, which chain is this? $2032 might, it's a somewhat high number, it might be interday, maybe. Okay, 2032 interlay, yes. So someone crossed out Bitcoin to interlay, but it's not really a lot, I think. Could be maybe a few $100,000 of worth. Okay, what do we see here? Dot being, what is the balance? Ah. 129 dot. But where is it transferred? It's to a different account on the same network. Okay. Okay. Interlay token going to Interlay. Dot going to a different address. Ah, is it maybe Polkadot? Is it going out to Polkadot? I think it's going to Polkadot. So someone is transferring out dot to Polkadot. How much? Small amounts, 350 dot. Or I am miscalculating something here. It's also possible. Because there was this last claim here. You see, swap aUSD. Maybe I'm running the numbers wrong. Dot token decimals 10. Okay, my mistake. 10 decimals, not 12. Okay, so that is much more. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and this is too much. So it's actually 10,000 dot. 1,000. Ah, I'm missing things up. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. Yeah, so that's 10,000 dot going out. And this means I was reading this one also. Oh, this is Bitcoin going out. Ooh, this might have been more Bitcoin. This might have been more Bitcoin. Interlay IBTC decimals. Decimals. 10 token decimals for Inter and for IBTC. 10. So okay, so again, looking at again with 10 token digits. So how much is being transferred out? 1, 2, 3, 1, 2, 3, 1, 2, 3. 0.1 Bitcoin. 0.12 Bitcoin. So how much is it today? 42,000. So that's 24,000. So $2,000. That's not too bad. Let's look at the other transfers. Okay, Akala has shared with me a list of tokens that have been identified, addresses. They seem okay. So we have what we have here: dot being transferred out. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. Okay, so that's 13,000 dot being transferred out. 13,000 dot being transferred out. 13,000 dot. How much is a dot? Okay, a dot is $9. So times 9, 117,000. 117,000. What did the person do with the other tokens? Ooh, he got 1.8 Bitcoin, IBTC, and it's bad for you, my friend. Bad for you. He tried to swap. Watch. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They have one more. Akala has. Oh, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Akala has a few more addresses that minted or that participated in unexpected mint. Okay, so maybe Akala is also aware of another aspect of that thing. Interesting. Good. So, okay, so what I would be doing now is looking at this account who got minted about 80 million aUSD if I'm correct. And I would try to find out how they transferred out, what they transferred out. So I think I'm just creating maybe just one sheet for them. You're curious why they deploy a different code than on Kusama. I mean, there should be minor differences, but I think they in general, they would be deploying experimental features on Karura first, but I know that so Akala, for example, they have deployed the liquid crowd loan token, the L dot. This is a feature that is exclusive to Akala, and it is not happening in Karura. Yeah, I'm curious too, but I guess there was no chance yet really to do it for Karura. And so they went exclusively with Akala because they didn't have it at the time when they went with Karura. Okay, I'm interested in this guy here who might have taken up to 80 million, but we have to look it up here. So I'm creating a little bit of space for him here. And maybe, yeah. Okay, so, and I'm going to look at what he transferred out, and we're going newest to latest. So transfer. Oh, okay. He also transferred out some AKA to another account. Thank you, sir. Okay, so to what currency amount? Okay, so he did an internal transfer of AKA, which is 12 digits, I suppose. AKA token decimals 12. Okay, so 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So this is AKA 4775. I think that's not too much. He tried to spread and maybe link. Have a link here. Okay. Okay, what do we have here? Transfer out the interlay token, inter, I guess. And how much? Oh no, this is IBTC actually. This is IBTC. And yeah, this was 1.8 because it has 1, 2, 3, 4, 5, 6. No. Yeah, this is 1.8 IBTC. This is the link. And where did it go to? To interlay. Let's add a new column here. Chain address. Okay. So, and it's interlay. Okay. Good. Okay. Yeah, so this is the heaviest so far. This is like $4,000-$5,000. Okay, what do we find here? This is a foreign asset for this is the inter token. This goes out to interlay, I would guess. Same address. And what we're having here. You know what? Maybe we just say balance. We post it here, and we say decimals, and we calculate it. And I don't have to count it every time. This is 10 decimals, and this is this, maybe to the power of 10 to the power of 10, and we divide E4 like this. Oh, doesn't work. 10 to the power of. Oh yeah, this is the inter token. Okay, so if we do the previous transaction, I think this should also check out. If we do this with the power of 10, and we check this out, right. Oh, and you see that I have made a counting mistake. Did I make a counting mistake? Nope. So maybe I should reduce it by 1. No. Yeah. Okay, if it has 10 decimals, that's 10 items after the dot, right? Yes. Okay, so it's not too much Bitcoin that he got out. Okay, counting this one. Dot. So, and this goes out to the relay chain. Yes, I think this goes out to the relay chain if I see this correctly. So, it goes out to the relay chain. I didn't copy the link here. Copy. Okay. And so this is dot here. I'm counting dot. How much dot is it? And how many decimals does dot have? 10. Yes, 10. So okay, 4,000 dot. Yeah, his balance says 1.8 IBTC, but this only means that he has that in that account. So, you know, maybe he made a mistake because he wanted to transfer out 1.8. He wanted to transfer out 1.8 Bitcoin. You know, look at this. He wanted to transfer out, but he made a mistake by 2 decimals. He made a mistake by 2 decimals. He put in 2 decimals. Look at the value. He wanted to transfer at 1.8 IBTC, but for some reason he got the decimals wrong. He only could transfer at 0.01 Bitcoin. You know, we can take a look at Interlay if they received the tokens. Should we do that? Let's try that for a second. That would be funny. That would be funny. But still, we are missing 18 million aUSD if my export is correct. So let's take a look at that first. Okay, but this is a good way to test out the account transfer here. Yeah, that's right. It's the same value. Okay, public key to Interlay. Okay, so let's see if my assumption here is correct. I mean, he has a little bit of a balance of Bitcoin. I would be happy about... Oh no, that's Inter. There's no Bitcoin here. There is no Bitcoin here. Utility bachelor. Okay, when did the transfer here happen? 70 hours and 49 minutes ago. 70 hours and 47 minutes ago. So, request redeem, amount wrapped. Ooh, I guess he managed to do it. This looks interesting. Account ID. I'm looking for a value here. Amount wrapped. He transferred 1 million Inter away. Okay, so he created a new account and then he transferred 1 million Inter to another account. And he requested a redeem 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that would be 0.03 Bitcoin. Huh. So, my friend, where is your Bitcoin? Where is your IBTC? Huh? He transferred it. It was transferred, or he transferred it to the fees module. Okay, who initiated that? Was it him? I forgot the address. Okay, another address initiated the call. Redeem, execute redeem. Transfer the Merkle proof. I don't know, man. Okay, this is an interesting subplot here, but I'm not really sure. Let's take a note. Has 1.8 Bitcoin on Akala. Seems like he wanted to transfer out the full amount and got the decimals wrong. Okay, let's still stay. Okay, I don't know about what happened here. This looks interesting. Looking at the link here too. Yeah, not sure really what's the story here. Oh, but this looks interesting. This is $50,000 he got out on Polkadot. Let's follow this one. Let's see what's happening with $50,000 on Polkadot. Can I search like this? No. Account format. Gene. Okay. So my friend, do you have 50,000 DOT? No, you don't. Did you transfer them? Holy 17,000 dot, 50,000 dot, and another 50,000, 100,000 dot. That's $1 million. That's $1 million. That's $1 million that our good friend got here. So I guess we could follow this in some reverse order. But $1 million. Okay, I'm going to relay this information to my good friend. Okay, wow. What an evil person. Transferred out 107k dot from this account. So it seems like he transferred out huge amounts of dot in the decimals and IBTC. Maybe on the way I made a mistake on the decimals and IBTC, but I'm not really sure. It doesn't seem like the account on... It doesn't really seem to me that the account on Interlay didn't really got in possession of that many tokens. So the person might have made a mistake here. You know, there's Inter here, and for some reason 16 hours ago this IBTC got taken away. But I mean, what is 1 million Inter? That could also be worth something. I don't know what's the price of Inter. Inter was there. Yeah, 0.1 USD, so that's also 100,000 USD. Not bad. $130,000. $130,000. So maybe I take a note here. Yeah, if you could rescue that amount of Inter, secured 1 million Inter, 130k USD. Okay, so taking out several steps to get out the tokens. I guess the person also got lucky and tried to get them out over several routes, or they actually claimed. Okay, I mean, we are still on top of this, so I guess this is the remainder of what they tried to get out. I guess if we go back to the original, we will see the much more interesting transactions coming up. Okay, what is this? Withdraw DEX share, aUSD, and Inter. Remove liquidity. Okay, maybe another. Seems like another. Could it be that another pool was also affected? I'm not sure. Maybe this would be interesting to investigate if the Inter aUSD pool also was affected. Okay, in the end, it seems like he tried to remove all liquidity and get everything out. So 18 hours ago, he couldn't look. There were swaps failing. Maybe the person was suspecting that the store is ending. Yeah, maybe the person was suspecting that the store is ending and tried to get everything out. Yeah, you see, maybe the council was taking over, and they realized, look, failed transfers. Maybe they realized what was happening. Yeah. Is this the last claim, aUSD? Let's see what happened in this last claim. So this is block 9081, 9081.10, index 10. Do we have something here? Let's 9081. Ooh, this was something different. What did you claim here? aUSD? Why is this not on my list? Why is this not on my list? Maybe it's in the unfiltered list. Is this the right address? Yes. So maybe he claimed something different here. 9081. Yeah, he claimed ACA. How much is this? 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. It's not too much ACA. 5 ACA is it? So, try to claim, nothing to claim. Try to claim 9074. 9074. Yeah, this was the last big claim. This was the last big claim with 40 million aUSD as a result. Let's cross compare it. Wrong link. Let's cross compare it. This claim should have yielded 40 million aUSD. Yeah. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so we can't. Yeah, this is 40 million aUSD. Lucky day for you, my friend, but you couldn't take the money, could you? Okay, so our good friend here is claiming 40 million aUSD. What do you do? Withdraw share, claim rewards, remove liquidity, swap. But the swap fails. Why does the swap fail? You're not providing any arguments. Swap aUSD for IBTC. Okay, so he's swapping in minimum target amount, supply amount. Okay, I'm guessing this is 52 million. 1, 2, 3. 1, 2, 3. But I mean, this is stupid. The pool is very empty. I mean, okay, you can claim if you take a valueless token that for the moment was valueless, you can claim, you can put all in. But you basically, our good friend here paid 52 million aUSD to retrieve a minimum amount of IBTC. Yeah, yeah. And you also know, at this moment, the market maker, whatever is, the pool might be empty. Yeah, maybe the pool was emptied. Okay, so what did he receive? This was transferred out. This was transferred in. Yeah, so he got tiny amounts of IBTC at this moment. Tiny amounts of IBTC. But it seems like he couldn't transfer out the IBTC. So this is a bit of a mystery. Holds 1.8 IBTC. Ah, maybe this module here is counting it wrongly. Maybe this is a wrong counting here. Could this be the case? Maybe. Okay, let me check the chain state because maybe Subscan is counting it wrongly. That's also possible. I would be going to Akala for a second, but maybe in a new tab. I would be going to Akala and check the chain state if it's actually so we would be checking tokens, accounts, and we would be checking this account here for IBTC. I think it's called KBTC on the chain here. New. It is a foreign asset. It's foreign asset free. Is it empty? The address is correct. IBTC. Foreign asset free. What is up with that? Do we find any token here that that is correct. 0. Okay, maybe Akala works differently. Reserves. No. Why is it shown as empty? Maybe they emptied the account, but I don't think so. Huh. Okay. Another mystery. Yo, dude, shout out to Symbian Flu. Yeah, okay, so this this guy here, but how did he got out the the huge amounts of dot? So he has received them at some point. Yeah, but it doesn't matter. So he got out 100,000 dot. Okay, so now everything comes together. He tried to use all the aUSD to buy tiny amounts of IBTC. Maybe also, okay, maybe all the other pools were drained also. Maybe the pools on Akala were drained, which would be bad. This would be bad for Akala. Because if all the pools are empty, they would have to account for that. So this is much less funny than it initially looked like. This is much less funny than it initially looked like. If all the pools got drained here, you know, $52 million for 0.009 Bitcoin. Maybe it seems like he crafted. Look at this. It seems like the person created the extrinsics in a tool, because he basically put in completely empty values. You couldn't. Don't think you could do this from the Akala frontend. So it looks like he got super excited and tried to send the extrinsics from here, from Polkalytics. Maybe he got this here wrong. Not sure about this. Can we see other DEX activity here? aUSD for Inter. aUSD for IBTC. But again, also small amounts. Very small amounts. A swap from aUSD to DOT. Okay, this looks interesting. How much is it? 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. No, DOT has 10 decimals. Oh, this is the max supply amount, so this is aUSD. So the person Yeah, interesting comment. So it shows that some is not decentralized. Accounts can be blocked because it can be stopped. I think the main line of thinking here is that we're thinking in terms of progressive decentralization. If you have a protocol in the first year of its existing and you have to assume that an exploit like this could happen, I think the company behind creating the protocol is happy that they can be stopping this. In the long run, we don't want to have a company being able to stop the whole protocol just within a few hours. And so I think this is where the mainline thinking of progressive decentralization comes in, which means that for now we have a council that is able, and on Akala and on many other parachains, there is a council which is consisting of 5 members or 10 members or 20 members that can perform certain activities and can, for example, stop the protocol. In the long run, we want to get rid of all the councils. We want to have a full decentralization where all the token holders have to vote on something like this. And this can happen when there is a lot of resilience in the protocol and is audit been audited and tested a lot. Right now, I don't think it's realistic for most protocols that are complex, like a stablecoin protocol, to be fully decentralized. I'm not sure how decentralized Maker is. This would be interesting to draw a comparison. Yeah. But what we at least can see is that you have a governance framework that you can inspect, that you can look into, and you know the structure of the governance framework. You can see the source code from which everything was built and how it is currently working. And what you, for example, could do is determine some sort of timeouts or slowdowns that could be employed in this case. Okay, so what do we see here? We see aUSD being swapped to DOT. And the aUSD has 12 decimals. So that would be 800,000 aUSD being swapped for DOT. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. 4,000 DOT. Okay, this looks like the pools got emptied. This looks like the pools got emptied. You know, 4,000 DOT for 800,000 aUSD. Seems like the pool's already heavily depacked. Okay, so publicly Akala could say that only 99%, so 99% of the wrongly minted tokens didn't got out of the system, which is good in a way. So it means that basically only within the Akala ecosystem all the pools got drained, but it seems like the DOT pool heavily depacked, the Bitcoin pool depacked, which wasn't too big yet, gladly, so it was maybe $50,000 or so, $100,000. But if you see Akala, so DOT getting out in amounts of 100,000 DOT, that's $1 million. That's $1 million getting out of the system. So it looks like the attacker got at least this. Yeah, more DOT. One DOT getting taken. Another X. Okay, we have an X token transfer here. What is it? IBTC. How much? 0.01. Not too much, my friend. aUSD for IBTC swap. Yeah, the pool got drained. Pool got drained. Okay, let's close the investigation down here. Okay, this seems to be where the most of the DOT got out. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. Yes. So 129,000 DOT. This hurts. Ouch. Ouch, 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 ouch. This is where the DOT gets taken. Okay, so 129,000 DOT. Oof. $12,900. What is wrong with my counting? Okay, good that we're making a cross check here. Is it the same address? Yeah. But that means he has to have more X. Yeah. Inter dot oh yeah, yeah, this is where a bunch of the tokens get taken. Ooh, that is just painful. Okay, but we see that this this is all the pools that got drained. It seems like there were not too many pools I'm not too familiar with Akala. I use Karura quite a bit, but I'm not using Akala yet. And it seems there weren't too many liquidity pools because usually Akala is putting against the Karura. They're using a lot of pools against aUSD, and if all of those get wiped, it would be bad. It seems like only DOT got wiped here in a very large amount. Okay. Let's close the investigation on this account because this seems to be the biggest attacker here. I would be interested to take a look at this account. So everyone above a million, and maybe this one because he has 16 transactions supporting this. And it also seems that AK seems to be a concern, so we can take a look at this also. But let's take a look at this one first and then go bit by bit. Not sure. I think I still go with just aUSD for now. Let's clear this one out. Oops. Let's clear this one out. Select this one. Okay. Okay, we can only consider everything that happened after this moment. But also, this person got excited. Boom, 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 boom. I mean, I would get excited if I suddenly have 24,000 aUSD in my account. Okay, so let's investigate this account on Subscan. One dot. Huh? Did I make a mistake? Did I make a mistake? Oh, Polkadot. Oops. Akala. $2 million aUSD in your account, my friend. So you already got some money there, and you couldn't transfer it out. Try to transfer. Oh, tries to transfer out the tokens. Interesting. Okay, so looks like this friend here couldn't run away with their claim. Stuck with the claim. LC dot. And is continuing to try to transfer out tokens. Yeah, too bad for you. But a lot of failed transactions on this one. Okay, swap, token transfer. You could transfer out some dot. 1, 2, 3. 1, 2, 3. 1, 2. Okay. I'm getting tired. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1. Okay, that's 1,500 dot you got out. Still $10,000. I think we put an X here for bad behavior. You were trying to steal our money, which is not very nice. It's not very nice. Okay, what about this one? Wait, what is your balance? That's a small aUSD balance. Looks like you've been naughty too. X tokens transfer. Dot. $260 dot. I think this person was late to the party and couldn't really, yeah, late to the party and couldn't claim a lot of dot. Late to the party and couldn't claim a lot of dot. Still tried to be evil. Oh man, just looks too easy for some people. Okay, 1 million dot in your account. You tried to transfer it out, of course you tried. Do you even have any dot? Bit. Okay, so it seems like people discovered what they could actually do. There was a huge amount of inflation and the system just exploded. Maybe aUSD depegged and the Oracle got it wrong somehow. That could be part of the story here. And the question is just how much dot to go after here. I'm a bit tired. I would like to wrap it up here, but to me it looks like, let's put down some findings. Let's put down some findings. Let's put down some findings. A few people discovered the possibility to mint aUSD, to mint huge amounts of aUSD. All pools connected to aUSD got drained, especially aUSD, IBTC, Inter. Yeah. Dot and Inter, dot and IBTC. Yeah. Okay, so basically it seems like what we have to go for now is look at the tokens that got out of the system. They have to get behind the tokens that got out of the system and hunt them and try to get anything that anyone stole and try to get that back. Because we see at least $1 million of value getting taken. At least $1 million of value taken in the form of dot. We see IBTC taken. That's a bad incident. Oh, and the system thinks that 3 billion worth of $3 billion of TVL out there, and there's a volume that is just insane. And one Bitcoin is worth $650 million. Okay, I have to check if there's still someone here. Oh, we have 22 people suddenly on the call. Okay, hi, welcome back everyone. I was thinking that the stream is actually going down. Yeah. So where were we? Okay, yeah, the start site assumes $1 of value. The price of one Bitcoin is $650 million. Price of dot is $1,000. Okay, and what do we see here in the pools? Yeah. What we could take a look at is maybe we can investigate the chain state and how much was in the pool before the incident. I'm not sure if I can do this, but let me try. So what's their DEX? I think the palette is called DEX. Provision pool. Maybe this is maybe it's this one. And so they had aUSD dot pool, maybe. Do you think Akala will be able to recover losses back to users of the liquidity pool? Actually, that's the question in the back of my head. I assume that Akala is fairly liquid in terms of money. They might have some form of, I'm not sure if it's an insurance, but I guess they have some form of coverage for this type of incident up to a certain amount. If it's under quotes just $1 million that I'm seeing right now, I think they can get away from this by covering it internally, and of course it hurts quite a bit. I think we have to determine the amount of value that got actually taken, and this is what I'm currently trying to do. So aUSD dot, I don't think that was the pool. Okay, with dot LC dot. Yeah, we have dot LC dot, and dot is basically just bound against LC dot. So we have to see what was aUSD bound against. Hey Dustin. Okay, so short summary for everyone who just joined the call. We were investigating what happened with the aUSD. We were investigating accounts that discovered the issue. We saw that the account that under quotes profited the most from this, so the account that got the most aUSD didn't try to exploit it, but we see a few accounts below this that tried to exploit the issue. Yeah, these are accounts that are not as visible as the other accounts. I'm seeing 3, maybe more accounts that look suspicious in their activity and that have taken a lot of tokens off chain. I only investigated aUSD, the trade of aUSD. It might be possible that other rewards were also minted in two big awards. I don't know this yet. And I have to get a little bit of water, so you have to excuse me for a minute. And what I will be doing next is I will be trying to find out if we can see how many tokens there were in the liquidity pools and see how much was drained. I could see that this account here was draining over 100,000 dot. It looks like 117,000 dot was taken. I'm going to continue my investigation a little bit more, but I have to get some water to not dry up here, so my body also needs a little bit of liquidity. See you in a minute. Okay, I am back. Yeah, so the activities that I saw being performed the most was draining of the IBTC pool and draining of the DOT pool here. And judging from the volume here, yeah, we just have to take a look, but it seems like IBTC was drained the most. Okay, then let's go for aUSD IBTC and see what we can find here. So I assume this is a foreign asset and it's asset free. Let's see if this pool exists. 0. Okay, let's try token and see if we can find so we find KBTC here. Yeah, this is something I was wondering before. liquidity pool. Okay, ACA, no, so okay, let's try A and foreign asset free. Yeah, so this is the liquidity pool between aUSD and IBTC. Yeah, okay, so we are counting the zeros here, and for aUSD, I'm losing my concentration again. aUSD token decimals is 12. Oh, that's the liquidity pool. Okay, ACA 12, aUSD 12. Everything moved .10. Okay, so with this information we can see that 12 decimals here. This is the amount of aUSD in the liquidity pool. Can this be right? This would be 1 billion aUSD. This looks a bit weird to me because from my summary here I'm not seeing close. This doesn't really add up to me. It confuses me. And what is this? This is IBTC. This seems to be almost empty. But 12 digits, this would look like there is 1.6 billion aUSD there. But we know that this guy hasn't acted bad. He just has the token sitting in his account. Oh, but did he have it in the liquidity pool? No. I think he removed the liquidity, did he? Yeah, he has it sitting in his account. Maybe he removed the liquidity. I don't really know. Okay, but this isn't even 0.2 Bitcoin. This is 0.02 IBTC, because there would be another 0, that's the 10th digit. So this is 0.0227 IBTC, and 1.6 billion doesn't really add up to me, but let's look forward. Block hash to query it. So I never have done this, but maybe we can do this together. So this is a block hash to query, and I would like to get a block hash before the incident, ahead of the incident, before the time of the incident, because maybe this would allow us to see how big the liquidity pool was. And I know it was created here, so it has to have happened sometime today before all of this happened. Okay, so this was 19 hours ago. This is when they became aware there's something going up. Yeah, and here you see the block hash. So maybe we can go a few hundred blocks ahead of that before all of this drama started. Let's go to block, I don't know, 5,000. There should be regular trading activity 1 day, 8 hours ago. We don't see anything here, and we take the block hash here. This is the block hash, and let's try to do this and see if we can find the state of the liquidity pool at that point in time. Nope, doesn't look too good. Maybe that was too quick. Okay, let's go to 8,000. Is there a solution to resolve this mess? Okay, so what is the solution? Akala has to try and stop all funds that are moving, try to maybe talk with other parachains that are affected. Maybe they can, I don't know if there's an emergency resolution for Polkadot to stop the tokens. I don't think so. So if we take a look at the tokens that got transferred out, so this guy was especially evil for transferring out 117,000 DOT. Let's take a look at this. emptied his account, transferred out 117,000 DOT to different addresses that I would assume belong to a centralized exchange. And I assume he has hit the centralized exchange and the tokens are gone. Let's take this one as an example. 75,000 DOT. Got the tokens in. This looks interesting. This was an account that was active before. So he rescued the tokens out to an account that was active before. And he has them now sitting here. Yeah, but the question is, will we catch this guy? If he has them just sitting here, there could be an emergency resolution from Polkadot from Akala presented to Polkadot to freeze that account and then transfer them back. I think this would then go to a vote on Polkadot, where all of the token holders would be voting if they want to have this. And I think this would come out positive for Akala. And then the tokens could be returned. But the question is, where are most of the tokens going? Have they been transferred out? We saw that IBTC went out a little bit, and we can take a look at where the Bitcoin went, the IBTC. If it went out and it cannot be recovered, then Akala has to come up with the damage. Or I don't know if there's a haircut, or if they say we refund everything. That remains to be seen. Yeah, and if they can recover some of the loss, then they will recover it. Or maybe they will tell users they will recover it over a certain amount of time. We have to see this. Maybe it can be found out how this account initially got seeded, for example. That would also be interesting. Yeah, let me find out a little bit more if we can see how much IBTC there was in this pool. So I'm trying a block. I'm trying this block here, trying to find out if I can with the proper hash at the proper point in time. It's also possible that the node doesn't secure the data so far back in time. But it would be interesting. You know, now I'm seeing something. Okay, but the pool was already emptying. There were already 51 million tokens. So this happened pretty quickly. Seems like this happened pretty quickly after the pool got initiated. So we might have to look even closer. It seems like the pool opened and then shit started developing pretty quickly. Yeah. Okay. Yeah, it's okay. So this is interesting. There were 115,000, and for some reason, something about the amount of IBTC here doesn't look right. Maybe they have only 8 digits on Akala. I don't know. Okay, so but this pool got emptied because by now it's like a lot of aUSD that's in the pool. A lot of aUSD that's in the pool. This would be 1 point. This is more aUSD in the pool than what actually wrongly minted to different users. This looks difficult. This looks difficult to comprehend for me. Maybe there isn't a second issue that we're not aware of. Maybe there's a second issue that we're not aware of. Okay, let's find out how much dot there was in the pool. So that was dot LC dot. Dot LC dot. Okay, let's find out how much dot there was. Dot. And token, not L dot. This has a different symbol. Liquid crowd. Ooh, I forgot the ID. Forgot the ID. Maybe I can find it here somewhere. 13. Okay. So let's see how much dot there was in the pool. Okay, so dot LC dot. So how much dot? 1, 2, 3. 1, 2, 3. Zack. 237,000 dot. 237,000 dot. 237,000 dot. Let me secure this one. 237,000 dot. And how much is it now? $172,000 dot, which would mean that 65,000 dot were taken. 65,000 dot were taken, which doesn't really explain how this guy could take 117,000 dot. Okay, so maybe my block hash is still bad. Maybe I still need to find a better block hash than this one. So let me go to a block that is again somewhere in the middle here. Before all this shit happened, and we try again. I think for this one I can go back further in time. Okay. Okay, 60. It looks like there was 67,000 dot more in the pool. I'm not sure if this is correct. Maybe people started draining the dot pool first, and only when the dot pool got drained, they started going to the other pool. Okay, let me go back further in time because this pool has been existing for much longer. And we do another check. Oops. Oopsie. Okay. No, doesn't seem too bad. It seemed like, let me count again, 10. It seemed like 238,000 dot were in the pool, and now there are 173,000. So 65,000 dots stolen. It doesn't explain where the 10,000 dot come from, that, or where the additional 50,000 dot come from that this guy was stealing here. That's odd. That is odd. So maybe I'm missing something here. Because what I'm seeing here, these are all successful transactions, and he was taking 117,000 dot that he could steal. Maybe we should look at this differently and find all the cross-chain transfers. Okay, let me think if we should continue or if we should stop it here. Okay, I would be focusing on this guy because this is the most interesting thing here. Why stop, sir? Yeah, my brain is freezing a little bit. I wonder in which direction we're going. I would say I'm taking a break here because my brain is really slowing down right now. It's late in the evening here. I think this is everything that I could show for now. It also showed to me that the issue is more serious than I expected, but it might not be too bad. I cannot see that too much dot was taken, a little bit of IBTC was taken, so maybe Akala is happy that not too much value was yet on the network. Maybe we can see this here. Maybe we can just see this in the historical statistics, or they just exploded. And we can see, maybe we can see remove aUSD, add aUSD, swap. Maybe we can see a few of the swaps. Token amount to IBTC. Did someone take to IBTC? 26J T2K. Okay, I gotta hang up again and try to come up. 262 TK. Look at this. But this is our friend here. Did our friend swap 400 million aUSD for 2 BTC? I don't think he did. Let's take another look. Maybe I missed something. But he didn't really have IBTC on his account. Maybe the whole system is counting wrongly at this point. Swap 52 million A. Yeah, this was another attacker. He got IBTC, and he got IBTC, but he didn't do anything with the oh, he added it back as liquidity. He added it back as liquidity. He added it back as liquidity. That's a nice guy. Adding 1 billion aUSD as liquidity. Yeah, this is our evil guy here. Yeah, and here this is also the evil guy who tried to get out the small amounts of IBTC. Maybe Subscan showed the user interface wrongly. Swap IBTC for DOT. Okay, but this could also mean that we're seeing the previous DOT transactions here. So maybe we can go to the pool here, the assets. Maybe we can see all the DOT related transactions from previously. DOT. Balance 1 million DOT. Can an account hold 1 million dot 10 decimals? Total supply 1 million. I did count wrongly before. I did it counted wrongly before. Is it possible? I'm a little bit confused why we have 10 decimals here, and this is a total supply of 1 million dot. And here we have, if we subtract 10 decimals, it would be 100,000 dot. This is maybe not a liquidity pool. This is what a certain account is. There is an account holding 1 million dot. My friend, what do you need 1 million dot for? Insane. Insane. Okay. Okay, but let's go back to the pools then. Then I was at the wrong page. I was at the wrong page. And we have a price of okay, so it would be nice to see how many dots there are. Swap dot for ACA, swap dot for ACA, dot for ACA, dot for ACA, dot for aUSD, dot for aUSD. 15 dot for okay, I guess someone, ooh, okay, this also went into the other direction. People tried to arbitrage. Okay, I just see one user posting, hi sir, cheaper here, hi cheaper. Missed all the fun, I just got some time online. What do you think overall? What do you think Akala can solve this without a rollback? Okay, I'm giving a short summary. We have been looking at the on-chain activity. It seems like there was one user that was discussed a lot today that minted 1.2 billion aUSD. A lot of the discussion was around him. In the meantime, at least three people, maybe more, actually stole value by transferring out tokens. They minted less aUSD, but they did more damage with that. That's what I see. What I see right now is damage amounting to at least $1 million in value, a bit more. And I'm currently trying to assess if the damage is bigger than that. And with damage, I mean tokens that got transferred out of Akala and are currently sitting in Polkadot or sitting in Interlay. This is the damage that we currently can assess. What can Akala do to solve it? It hasn't, so at least some of the tokens I thought haven't been transferred out of Polkadot. And so it is possible that if governance action there is swift, it might get frozen in Polkadot and maybe retrieved. We have to see. And it's going to be interesting to see what if this is sort of how do you say in English? Like the first time something happens. A precedent. If a precedent is set up, if Polkadot will try to help in recovering those tokens or not, by working with exchanges, but at least governance action can jump in and try to secure the tokens. Yeah, the question. Someone is asking a question. Augustine is asking a question. People made money with this hack. All actions were paused by Akala. I see that a 350,000 balance in my account right now. Any benefit from what when you could swap? Yes. So what we have seen is that a lot of DOT was swapped out. I'm still trying to understand it. Sometimes it's a little bit hard to read Polkadot.js. We were reading through this before. It seems that DOT was taken and that IBTC was taken. There aren't too many liquidity pools on Akala yet. So there isn't too much of value that could be stolen, but we see that DOT was stolen. At least 117,000 DOT was transferred to Polkadot. Yeah, right. And so what we were currently doing, I was starting to get a little bit tired, but I'm currently following the official statistics page of Akala to see what happened with the DOT. I wanted to find out how much DOT was in the liquidity pool before. judging from Polkalytics, it was roughly 238,000 dot. And right now the pool would sit at 172,000 dot. But that would only explain 65,000 dot missing, and I'm actually missing more dot because this account here transferred. We were tracing one account just before that was transferring 170,000 dot out. That seem to be related to the incident. So if they are related to the incident, the question is, where did they come from? Currently, I can only explain this from the liquidity pool. These were the tokens that were in the liquidity pool, so that's the .lc pool. And I'm currently trying to find out more about other pools. Yes, so that's where we are. The investigation is going slow, and we are discovering new things as we go along. Dot failed LC dot for ARCA, but I'm actually looking for aUSD for dot. But maybe this is the wrong direction. aUSD for dot. So yeah, in the end, it was hard to get any dot for aUSD. But the other thing, so this is the interesting thing that people maybe indirectly participated. So it seems like the dot, sort of the dot to aUSD ratio depegged in a way, or got off balance a lot. And it seems like people tried to arbitrage this. And this is an interesting people. How do we deal with people that just tried to arbitrage the situation? Because they could profit it. So let me get out an example. 7 dot for 7,000 aUSD. Yeah. So suddenly the relationship dot to aUSD was 1 to 1,000. And for 1 dot you could buy 1,000 aUSD from the liquidity pool because it depegged so much. And there were people seemingly trying to arbitrage this situation. There were people trying to arbitrage the situation, and the question is now, will they be punished or not? Let's put this on a list of questions. What will happen to accounts that tried to arb for profit of the depegged pools? That's an interesting question because this one is not easy to answer. For any attacker, you can just say, we try to freeze the accounts and get it all back. But what about people that try to arbitrage the situation? Maybe they try a full rollback. Yeah. Another question, why is Karura not affected? Basically the same pool. Yes, basically the same pool, but maybe within Karura, there wasn't this huge... So the mint issue was only constrained to one pool, and that is the aUSD IBTC pool. Somehow the rewards there got mixed up. I have secured the transaction. Somehow the rewards there got mixed up, and maybe this was the issue. Maybe there were too many rewards minted for just that pool, and the only other ecosystems that were affected by this was Interlay, because there was some interaction with Interlay going on, and Polkadot. But the damage from this submodule didn't spread out much further. And so Karura, which is on a different security umbrella, under the security umbrella of Kusama, wasn't even affected by the issue. Yeah, okay, how did aUSD went down to 0.02? Why sell that cheap so fast? Basically, the issue compounded. We can take a look at the exhibit number 1, the person that got put into the spotlight the most, by filtering how he started compounding rewards. So he basically could start compounding. He only did it 3 times, so it wasn't too big of an issue for him. But you see, 3 transactions that started compounding 3 digits every time, 2 digits every time. Yeah. So first he got 33. So from $600 he made 33,000. From 33 he made 50 million. From 50 million he made 1.3 billion. So he compounded this. There were attackers that were a little bit more sophisticated. They tried to do it more often, but also tried to steal money while they were also compounding rewards. So it was slower. 60,000, 140,000, 300,000, 400,000, 1.2 million, 4 million, boom, boom, boom. This was, I think this was the person that profited the most because they got out at least 100,000 aUSD. Yeah, aUSD is not bridgeable yet. The problem could be bigger if the connectivity was better. That is right. So maybe we got lucky in a sense. Maybe we got lucky because right now the damage that I can see is roughly $1 million. It could be bigger. I'm trying to nail this down. What I'm getting here, I want to take another look here, is the governance call that originally created the aUSD IBTC liquidity pool. So this was a pool, this was a call voted on by governance, and I learned a little bit more about how the decimals work today, so I want to take a look again. Okay, the first call was setting up the bootstrap. This is setting up the bootstrap with the targets. So for example, they tried to 1, 2, 3, 1, 2, 3. They are having 8 digits here. Because the goal was, okay, now I have the proof. Because the goal was initially to have 1.1 IBTC or 25,000 aUSD. So that's 1.3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 25,000 aUSD and 1, 2, 3, 1, 2, 3. You know, it should be 10 decimals. So it should be, there is a mistake here. This is weird. We've been seeing this issue that there was a mix-up between 10 and 8 decimals for the whole day. So maybe let's check Akala. Let's check the asset registry of Akala. Because this is keeping confusing me. Asset metadata, foreign asset, free. 8. Okay, so they're having 8 decimals. They're having 8 decimals. Good. So 8 decimals for IBTC. And this call, where is it? No. Starting getting confused by my own tabs. So this call asked for 1.1 BTC and 25,000 aUSD, and then there was a pause, and after the pause they wanted to set up the saving rewards. And so they wanted to set up the saving rewards for the pool aUSD IBTC, and this, I think, what is it? It is an incentive, but it's missing something. Maybe this was the issue? Yeah, because usually what I'm looking for is, maybe this was the issue. Update savings rewards. Update incentive rewards. Okay, maybe this is something different. Update incentive rewards, aUSD IBTC has a reward of AKA tokens. 1, 2, 3, 1, 2, 3. 1, 2, 3. 1, 2, 3. Is it 1.2 AKA per block? Or what is this? What is the reward? Okay. So this is the AKA tokens reward, this is the inter-token reward. Maybe this didn't even set up the reset. And then they have, okay, they have AKA rewards and they have inter rewards. And then they have a claim reward, so this reduced the rewards. Okay, so this was not the call that originally set up the aUSD incentives. This wasn't the call that set up the aUSD incentives. Maybe that was a different governance call. Proposals. Okay, let me investigate this a little bit more because there were no aUSD incentives here. People could not claim aUSD incentives from this one, I think. Or this savings rate here was the thing. Say update DEX saving rewards. Let's count what this is. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, something of 50,000. We don't know. Where did the aUSD incentives come from? Okay, this registered the Fala token. Update claim reduction rates, aka aUSD. Update claim reward deduction rates. Update incentive rewards, L dot aka. Okay. Well, I think I could spend forever just looking at this transaction pause. This is when shit started happening today. Okay, somewhere here, incentives, claim rewards. Okay, transaction pause transaction. Here they started seeing that something is happening and they stopped transactions. Okay, and then they tried to mitigate stuff. Yeah, they stopped swapping. Okay, this is where they stopped all the swaps. Stop all the swaps. Yeah, this is where they stopped it. So I think this was the aUSD minting. I can't really read it. I can't really understand completely what this call does, but to me it seems that this part here started minting aUSD. Okay, this is a good comment. So the damage is around 1 million. That's good. Akala had a 1 million bug bounty. Good thinking there. If we can nail down the damage to just 1 million, that would be good. But you know what? Could we determine the swaps, or would it be easier to determine the X tokens transfers? Okay, I might be doing one last thing and then I'm heading to bed. I'm doing one last thing and then I'm heading to bed. Oops. Yeah. So I'm looking at all the token transfers that I'm going to look at all the transfers of tokens going outward of the farm. This will take some time because I have to code some shit. Might not be interesting for everyone, I'm warning you, but it might be interesting. To me, it's interesting to code stuff where you can see value flows, and I would be interesting to see every value flow that happened actually. So let's start this. I'm getting one more glass of water and then I will write a small program that basically fetches all token transfers from Akala going out. Oh yeah, it's an exploit. Did I call it something differently? Sorry. Okay, I'm back. Okay. So in general, it's a bug and not an actual hack. Yes, sir. It was a bug, and the person abusing it was exploiting it. So this is why we call it an exploit. It wasn't. A hack would have to be more sophisticated. In generally, I guess a hack is usually is associated with getting past a certain barrier that was intended there to keep people away. In this case, no barrier was broken. The mechanics were just used, and in this case, it seems like the protocol just started throwing aUSD at people, and maybe ACA too. We don't know yet. It seems like the protocol just started throwing money at people, and they made use of it. Okay, last part of the session here. I did this before, and I'm a little bit tired, so I might get stuck here. But what I'm trying to do is I'm trying to read XCM transfers, the outgoing portion of an XCM transfer. I've never done this before, but I was reading so much XCM code today that I might be able to pull this off. And we're starting with the outgoing dot transfers. This is what interests me more. I want to see when dot gets taken out of the system. So I'm sort of stealing this piece of code here. So this is the portion where someone is sending dot off chain. I'm trying to comment. If I forget to comment something and you're just confused and don't know what I'm doing, just ask, because it's possible that I'm stuck in my head somewhere while I do this. Let me pull my code here and get the chat window up here. Okay. So this was the aUSD claim incident stuff, and I'm going to copy this, and I'm going to paste this if I'm able to. Okay, and so this is sample an XCM egress, so an outbound token transfer, and I would like to add the little bit of text here that represents this call, if I'm allowed to. Yes, thank you. Maybe I'm also, you're giving me the honor of formatting this for me. Okay, maybe not. Could you please format this for me? No. Okay, maybe I can lint it. JSON lint. Yeah, a little bit. This is good enough for me. It's just a comment. I don't need it to be good. Zack. Whoops. What did I just do? Okay. I'm making this a little bit smaller. I want to see a nice comments here. Okay. Okay, I'm looking at a call that's called, what's their name? It's called xTokens transfer. xTokens transfer. So what I'm doing here is I'm calling for Akala xTokens transfer, and I want to get all of these events here. xTokens transfer, and I will call this method fetch X token transfers. Okay, so let's go here. Okay, and what I will do now, in the first run, it will start, in the bottom here you will see activity, and it is starting to query for X token transfers. It would now, if it doesn't read a timeout, this happens sometimes. Okay, data parachains. Delete. Okay, let me try again. It's a little bit shaky, my module. Okay, so let me get back to the original. Okay, we're trying to query data from Acala, and it's empty. About to fetch 0 entries. Am I doing something wrong here? Acala X tokens transfer. Okay, let's see. Maybe I'm making a small mistake in how I write it. So the module is called X tokens, and the call is called transfer. Oh. X tokens transfer. And I'm looking for events. It is not right. Oh, this is interesting. I grabbed events in my previous. I grabbed it. How could I make that happen? I wrote my program with a wrong configuration and it still worked. Okay. So that was weird. Okay. Okay, yeah. So what my program is doing right now, it is scanning the network for those extrinsics and grabbing a list of them. Maybe I should even... Is this a regular transfer? Is this an internal transfer? No. Transaction payment. Yeah. Okay. So what you can see here is a lot of X token transfers, and I'm already happy with what I'm seeing. This is much more than I need. Yeah. Basically, I have the blocks that are relevant for is everything that happened today, and these blocks. Yeah? So we're starting to look at these blocks, and we're now going to start transforming that data to look into the data. What do you mean with my eyes closed, Alex? Okay, so on my hard disk right now, I got a list of X token transfers, so XCM transfers of tokens out of Acala. And we're going to scrape them now, looking at what we're finding here. Good. So, and this is where I am putting my breakpoint now. So I'm going to unwrap the data that we're seeing. I'm loading it from the disk, and now the program runs into an empty list. X tokens transfer. Oh, I'm sure I need to rename it somewhere. Yeah, so this is the storage menu. Okay. So my program is checking for all of the XCM transfers on disk, and it's giving me a list now. And the next step of what I have to do is I have to dig a little bit into this. This might get boring for 3 or 5 minutes, but after that we would be getting a list that we can then put into Excel. And in Excel, we can take a look at it in a format that everyone can understand. Okay, for now, I have to do the little bit boring work of looking at the params. Okay, and what I see here right now is actually this call. So what I'm seeing is this call, this XCM call, where someone tries to transfer a token. First piece of information we're getting is the type of token that they're transferring. This is how the system represents it, and what we're interested in is dot. We don't care about anything else here. It might just be that different calls set this up differently, so we just have to write the program in a way that doesn't break. So this requires a little bit of code on my side just to not make it break. And I will do this here. So what I'm doing now is writing a little bit of, so parents number one is the token. Retrieve params index 0 currency ID key. Let's see if GitHub Copilot helps me here. Yes. Maybe even and throw error if not found. Okay. Yeah, that doesn't help me too much, but let's see. It might just break, and I'm happy with this. Okay. Next thing I want to look at is the balance. Oh, yeah. Okay, the debugger broke, but actually I just need the balance here, which is this. But I'm missing the amount of decimals. This is really bad in a way, but we have to deal with this. Okay, so actually this should get unwrapped. Why isn't this unwrapped? I would like to see this unwrapped even more. It's okay. Amount. Oh, it's so smart, the thing. Do you see GitHub Copilot? I just copied this piece here, and it just gets it a little bit. Alright. But balance is wrong. We want to have... Yeah, we actually want to have the... Oh, did I read this wrong? I might have read this wrong. So let's just add a breakpoint here and let the program run until here. Params. Yeah, balance. Okay, so actually the program was more right than I was. This is irritating. Balance. Okay. Balance. And here we get token. Okay. Okay, now this one is a versioned multi-location. This might be a little bit more complex, but you know, let's just try. Retrieve the location of the transfer. So, wow. Okay, if this is true, GitHub Copilot is a true hero. Params to version 1, interior. Wow. Wow, wow, wow. X2, wow. No, come back. Okay, no, it breaks here at some point. So in this case, it's X2. X1 might be something different. Hi, Shiny D. Okay, I'm keeping this because this might be relevant later. But let's put X2 here. Okay, and then we get the parachain. So let's get one for the parachain. And this is X2 call 0 This is going to break a lot of times. This code is going to break a lot of times until we can make it work. Okay, so we're getting the parachain here, and the second thing is the account key. This is sort of the address, right? So we're getting the address. So address is okay, let's say this is the x2, whatever an x2 is. I don't know what an x2 is, but XCM people know what an x2 is. So I'm going for the x2 column 1, and then I have an account key 20, and then I have a key, and this is sort of okay. Let's try if I can run this and it won't break. Bark. It breaks. Okay, so params should be minor issue. Multi-location, yeah, it was right here. So, okay, so it's params. Wow, box versioned multi-location, and then we've okay. Might be as easy as that. List instances. What do you want? So params. I just copy this and see where it breaks. Break here. No. Oh, okay. The 2 was still correct. 2. Okay, to recover what we're doing here, we're going to look for an XCM outgoing transfer. We're looking for an XCM egress from Akala. We want to have a list of all tokens that are leaving Akala, and I'm currently creating the list. So let's assume that this one called, and at the end, when we have all this data gathered, we would put it in a list here. We would put it in a list. And so we have currency ID, balance, parachain, and address. So that's currency ID, balance, chain, and address. So it's target chain. Let's call it target chain and target address. This is where the tokens are going. Currency ID, balance, target chain, and address. Okay, so that's currency ID, balance, parachain. That's not too bad, my friend, but you don't know the... Oh, yeah, we could actually say we are taking... yeah, we don't know the address format. But let's put it out in a Polkadot format. So we're putting out the address in a Polkadot format, which is prefix 0. So prefix 0 here and prefix 0 here. And this might be it. And that's not all claims, that's all token egress. Oh, okay, and I'm not getting events here. What I'm getting here is basically, this is an extrinsic storage, and so we're not having events, we are having extrinsics. And so we're having an in extrinsic, and we're having an event, and we're having extrinsic. And let's see if this does not break. It will still break. Okay, so I'm taking a look at the extrinsic. It's built a little bit different from the Okay, and so this is not the event index, but this is the extrinsic index, of course. Okay, I'm getting the extrinsic index. Do we have a block timestamp? Yes, we have a block timestamp. Okay, should be good. We have an account ID actually. So I don't need. Okay, so this one is not param 0, this is actually extrinsics account ID that is sending the call signature, and we maybe need to say if the extrinsic was a success. So let's say extrinsics success, and this comes after account ID, so this is success. Okay, let's restart the program. Oh. Ah, yeah. Es ist 58. I think I need to reconvert this address. A little bit of bureaucracy here. Invalid length of address. Why is it invalid? Huh. Invalid length of address. Account key 20. Ah, I don't know, my friend. Make something up. Why can't you solve it? Ah. Okay, let's look at this index. Okay, so this is the extrinsic. This is the extrinsic we're currently trying to process. Doesn't appear. I'm a polka dot, not on color. Okay, back to a color. So what are you trying to achieve here, my friend? Okay, so this is account key 20, and this doesn't transform to, what is 2004? Oh, that's an is it an EVM address? This is an EVM address, is it? You are trying to transfer to Moonbeam. Okay, so if the parachain is 2004, you're trying to transfer to Moonbeam, and then it's not a Polkadot address. So I just need okay, then we just put it here in a raw format. Okay, so okay, let's break here. If we find a Moonbeam address, we would need to do something different that I'm not aware of how it would work now. So if parachain I know. So I just put the address here, and here I say if parachain not 2004, then we can transform the address, else we leave the obscure format. Is it like this? Yes. Okay. So this should help us. Parachain ID 2004. No. Okay, we said don't convert Moonbeam addresses. Convert address to their Polkadot address format except Moonbeam. Okay, so account key 20, I guess, is only for parachain 2004, and else else we would have to do something different. I hope this is the only special case we need to cover, and we have our list in a minute. Okay, go. Okay, so now we have a different case, and our case is okay, restart. You need a length for address. That is right, my friend. This does not belong here. It belongs here. Okay, yeah, I was saying no more special cases, but that's not true, because it's not always an x2. Sometimes it is an x1. So what is an x1? Interesting. Okay, so we have to split cases here. We have to say if x1 in then x1 equals but what is an x1? Is this a transfer out? That's a dot. So an x1 is a transfer up to Polkadot. Maybe. I would assume. Okay, so let's assume this is a transfer to Polkadot. I think this is a transfer to Polkadot, but maybe, yeah. Else if then we are doing all of this. And so we say parent chain equals Polkadot address equals, and I think it would be this, maybe. Okay, and there are situations where it's not version 1 of XCM. Oof, this XCM thing is a thing. Okay, my friend, this is version 1. Oh, no, we made a mistake. So that's box version multi-location. I somehow missed that. Haha, so much to, it's just 5 minutes. Version. Okay, let's retry. And I missed to close this like last time. Okay, let's do it again. Okay, so I'm getting an address which I should convert to a Polkadot address. And I want to look into this set first, just for a second, just to make sure I'm not missing anything here. So I would be inspecting this element, just to see what's inside there, but it's just the ID. Okay. Okay, I'm going to make an assertion just to make sure that I'm not missing anything. So I'm going to assert that ID, no, that the network any is none. This seems like a good assertion, because then I can sleep with peace and I can keep on going here. What is this? The currency ID is not a token, it's a foreign asset. Oof. Oof. So it's foreign asset 0. What am I going to do now? This looks interesting. So sometimes they're transferring out not a token but a foreign asset. But where is it going to? It's going to go to, it's going to Moonbeam. It is going to Moonbeam and it's a foreign asset. Okay, so if it is a foreign asset, I could just put out the key here, and as long as we don't have any other assets that are a key, this should work. So if if it has a key, if currency ID has a key foreign, what was it? Foreign asset, then set its value to set the value of currency ID to that. Else set the value of, right. Okay, works. Thank you, Copilot. Okay. So where are we? We are in X2 and we're getting a parachain, and the parachain is 2012, and we're getting an address. Oh. And so we're getting an account 32, account ID 32. Okay, so this is basically a reproduction of this code here. But it's from the X2. X2. Okay. I think we're coming to an end here. I hope. I counted E32. Okay. Okay, please. Yes. Okay, this seems to have yielded a result, so let's call this Kata X token transfers. And we're going to see in a minute if this is a meaningful file or not. Yes, sir, thank you a lot. So let's take a look at our result. How many people are in the call? 16. Okay. So transfers, X token transfer. We are going back to our original file here. Okay, so this is a aUSD investigation. We are creating a new file. So these were basically the claims. Oops, claims. And now we are taking the XCM egress. So this is all outgoing content, right? And we're going to import, and we're going to upload our Kata X token transfers here. And we're appending this to the current sheet and trying to determine everything automatically. Okay, so event index is basically the block plus a running number, which is the extrinsic within that block. Timestamp is the Unix timestamp. This is the actual readable date for humans. Then we have an address that performed the extrinsic. We see if it was a success or not, which is especially important today where there are a lot of extrinsics failing of tokens. We have the currency ID. We have the balance, which is dependent on the currency ID, so we need to map this a little bit later. Target chain and the target address on that chain. Very interesting. Right. So we need to determine the decimals here for each asset. So how do we do this? So let's make a table for the decimals, and I think so. Dot has no. Let's see. This is the ticker, and this is the decimals. So dot has 10 decimals, right? Okay, so let's determine if we can find the decimals. So the decimals would be a vertical lookup of, this is the search key, and we're looking it up in this range. And the index is 2, I guess, in this case, and it is not sorted. Okay, and so we need to add AKA, which has, I think, 12. Does it work? Yes. Okay, so we're having the decimals, and so we're adding the power of 10 to the lookup, and we're taking the balance and dividing it by this, and this is the amount of tokens we have. Okay, so amount. Okay, which means we can. Okay, which means we can hide these. Let's let it live here for now. Let's put this here. Okay. So we see outgoing transfers, and we first need to filter it by only successful extrinsics. AKA is going out, dot is going out. Interesting. Well, how is it sorted? Let's sort it. Okay, so this roughly covers 1.5 months. Let me sort it in a different order. So yeah, so this is when the last transfer went out today, dot, and you see how much dot went out. Okay, interesting. You see also that aUSD was transferred out to Moonbeam. So aUSD went to Moonbeam, aUSD went to Moonbeam. Okay, so we have bad aUSD going out to Moonbeam. This is interlay, so interlay tokens are going out. So basically we need to have 3, which is Bitcoin, and they had 8 decimals for this, and they have interlay, which I don't know the decimals. I'm trying 10 now, but it could be something different. Yeah, it doesn't look too bad. Okay, interesting. aUSD going out and IBTC going out. But so someone tried to get out 1.8 IBTC. Yeah, this is the bad attacker here. This is the evil attacker, and we got their address here. Okay. Right. Okay. So I would say we start. So what we see is, and now I think everything gets a little bit more practical again. We see that DOT went out, we see that IBTC went out, and we see that aUSD went out. And from the parachains, you can see there are basically the chains. Oh, there are multiple chains. Okay. But I guess for the latest incidents, you see the tokens went out to Moonbeam, which is basically bad aUSD. You see that DOT went out to Polkadot. You see that IBTC went out to Interlay. Okay. Yeah, so we have all outgoing values. We need to limit it a little bit by time, I would say. Okay, now we should know when everything started to happen, which I haven't covered. Must have been somewhere here. What did we see here? Dot. Are there any insane amounts going out? aUSD. Okay, how much does aUSD have? It has 12 decimals. 1000 aUSD going out. Okay, we would need to know the start of the incident, but it was somewhere around here. Somewhere around here. So let's just say anything from starting from this block. Can we filter by this? Let's go to this block timestamp and just ask for anything bigger than this block timestamp. And this is how we're going to filter this for now. Okay, so filter by condition greater than this value. Okay, we got a filtered list now. Okay, so let's take a look first at DOT. DOT is interesting to me. I think I'm most interested in DOT. How much DOT went out successfully? Right? Okay, let me sort it by amount for a second. Yes. Okay, yeah, okay, so we see the successful DOT egress, and we see that it's all related to this account here, right? So what we can do is we can filter it by address. So we're creating a new pivot, and we are saying for the rows we want to have the address, and for the values we want to have the amount, the sum of the amount. And I would assume this is filtered by DOT, but I can't be sure. I would be sorting it by the sum of the amount descending. Okay, doesn't look like DOT, so let me filter it by saying the currency ID is just the DOT token. Just the DOT. Yeah, and you see the evil guy here getting out 117,000 DOT. And now this is the question I wanted to have answered. You know, it's like an hour of work just to get one answer. This address here. So these are all the people getting out DOT from the system. And you see that there is another address getting out a lot of DOT. So let me check for this address here. Oops, this didn't work out. Okay, so seems to have been involved in an incident and sending out regular amounts of dot. Let me compare it. Yeah. Okay, yeah. So I'm cross-checking and Akala is aware of this person. Yeah, I should have put in the KSM address, the Akala address here. So akala.subscan.io. Let's see who this is. 253. Okay, so what are we looking for? We're looking for 253p. 253p, yeah, so this guy here got also out a lot of dot. Okay. Not bad. Okay, what about this one? Good amount of akka, good amount of dot. 25q. Q is not on this list. Q is also not another list. Might not be a bad person. Let's take a look. So this address doesn't currently seem to be suspected by Akala. 25q JI. Okay, so what did they do? Oh, go away. No. Stop. Sorry, I have a spam bot on. I have a spam bot here. Okay, sorry. I had a spam bot in the channel. Okay. Yeah, try to do stuff. Looks a little bit like a bot to me. This looks like a bot that has gone wrong. Okay, this might have been an arbitrage bot. Looks like an arbitrage bot. Funny. Okay. This is funny, this looks like an arbitrage bot. Okay, but I think this is the important question to close it down with, because I'm getting super tired again. It seems like these two extracted value on purpose. We would have to continue the investigation here. A total of 203,000 DOT were extracted from Akala during that time, and it looks like 165,000 DOT is concentrated to two accounts. I think that's the message we can close with, and with that I would like to thank you for being in the stream. I will be closing this down. I will be sharing a few of my insights on Twitter. Then I will go to bed. Thank you very much for joining. Goodbye. Have a